Hey, and welcome to section 3 for this course, where we're going to be building a game called Mars Marine. Unlike the previous sections where we create a project from scratch, you're going to be downloading an Unreal Engine 4 project that I've set up that contains a lot of art and audio content that we can use to build this game. But don't worry, there's no blueprints or gameplay built into it. We'll be building everything from scratch within this project. This is just so we have access to a lot of content to start developing the project with. So in order to download this project, you're going to want to check the resources for this lecture to download it. You'll find a zip file named marsmarine_ue4project.zip. So go ahead and download this file now, and while you wait for it to download, here's a sneak peek at what we're going to be building in this section.
Mayday, Mayday! Marine Squad Victor Foxtrot requesting immediate support in Sector 3. Surrounded by hostiles and taking heavy casualties. We need more firepower down here.
Okay, so Mars Marine, the game we're going to be building is a top-down wave-based shooter. The objective for the player is to survive as many waves as possible against some aliens. Now, once you have your project downloaded, you should have a zip file. Make sure that you place this file somewhere on your machine that you're happy with, and then we can extract the file or unzip it by right-clicking it and hitting either extract or unzip depending on your machine. Now once you do this, you should notice a few more folders in your directory, and you should see this marsmarine.u project. Now to launch the project, all we have to do is double click on this file to launch it. You'll only have to launch it once from here in this folder, and the rest of the time you'll be able to launch this from the Epic Games launcher. Now I'm still developing this course in Unreal Engine 4.20, but if you don't want to follow along in this version of the engine, you can always switch the engine version for this project by right-clicking on this file and selecting Switch Engine Version. Then you can select whichever version of the engine you want to use, then hit OK and you can launch it. So let's do this now. Let's boot up this project for the first time. When we do this, we should see the splash screen for our project while it loads. Now, when the project opens for the first time, you might see that it says compiling shaders. So this means that Unreal is just taking its time to load the materials for the level. So you'll have to wait until this completes. And you also might see that it says new plugins available. You can just hit dismiss to get rid of this message, as we're not going to be using any plugins. So this is our project now open and ready for us to start developing. You'll notice that the content browser is full of assets ready for us to start using. And we're going to be jumping straight into setting up our game mode and the start of our player character class in the next lesson. So once you're ready and you have your project launched, I'll see you in the next lesson. Okay, so with your project loaded up, you'll be in a level just called Mars, as this is set as the default level that the editor and the game will launch. This level is just basically going to be a small arena. Later on in this section, we'll be taking a look at restricting the player character so they can't leave this small arena area. Now, talking about the player character, let's jump straight in and take a look at how we can start developing our blueprint character class. Inside the content browser, let's create a new folder called Blueprints. Now remember, you can change the color of your folders to set them apart from other folders in the content browser. So let's change this folder just to be a bluish color, just to set it apart from all these other folders here. Now inside this folder, let's create another new folder called Pawns. Now you're probably wondering why I've named it Pawns, but we'll see why in a second, but we're going to create our character class inside here. Let's right click in the content browser and let's come up to Blueprint class to create a new blueprint class, and we started off this course by working with actors. Then we moved into working with pawns, but in this section we're going to be working with the character class, and it says here that a character is a type of pawn that includes the ability to walk around. So a character actually is a pawn. It can still be possessed and unpossessed, so we can take control of it just like any other pawn. However, the difference about this character class is that it already comes with components built into it that makes it perfect for humanoid-like characters. It actually extends the pawn class. So this is what we're going to use to develop our player character. So what shall we name this? Well, the player character for our game is going to be a Marine on Mars. So let's name this asset BP for blueprint underscore Marine. And remember, we have to use the underscore because Unreal doesn't allow us to name assets with spaces. Now, before we open up this blueprint class, we want to make sure that we spawn in as this character when we play the game, because at the moment, if we were to hit play, we would just spawn in as Unreal's default pawn that just floats around the level. So your challenge right now is to create a Blueprints game mode for Mars Marine. You might want to put this in its own folder too. And once you've created your game mode, assign the default pawn class to be the Marine character class we've just created. And then for the final step, make sure to assign the game mode as the default game mode for the project. And you can do this within the project settings. So pause here to create and set up the game mode. So in my blueprints folder, I'm going to create a new folder called game mode. And within this folder, I'm going to right click and create a new blueprint class, and I'm going to select the game mode. So we're going to call our blueprint game mode BP underscore Mars Marine underscore game mode, something like this, just so we know it's a game mode linked to our game. Now, if we open up this game mode, we can see on the details panel that we can assign a default pawn class. Now we want to change this from Unreal's default pawn to our Marine blueprint we've just created. We can hit compile and save to save the asset, and we can close out of this now. Now this still doesn't change much yet because we haven't assigned this game mode. We want this game mode to be the default game mode across every level in our project. So to do this, we are going to come up to Edit and then Project Settings. And then on the project settings, we're going to come to Maps and Modes, and here is where we can change the default game mode. We're going to change it to the BP Mars Marine game mode we just created. And we can also see here that Mars is the default map for the editor and also a packaged game. Now, even though we've done this, if we close the project settings and come and hit play and start to play the game, we still play as the default pawn. So why is this? Well, if we come up to settings and then world settings, you can actually override the game mode for each level. And it's still currently set as Unreal's default game mode, so let's change this to our Mars Marine game mode. I just wanted to make it clear that even though we set a default game mode for our project, we can have different game modes for different levels. Now you'll notice that if you hit play, that we can no longer move around our level, but this is expected because we are now playing as our Marine character blueprint, and this doesn't have any logic set up yet for our movement. Let's jump out of the game by hitting escape, and let's come back to our blueprints folder, and then inside the pawns folder to open our blueprint Marine character. In the viewport for our character blueprint, we see a couple of things here. We see this capsule-like shape, and we also see an arrow. If we look over to the components section, we can see that the root component is a capsule component. This is going to be used for colliding with objects in the world. We also see an arrow component. This is just to help us see the forward-facing direction of the character in the editor. We won't actually see this during gameplay. And we also have a mesh component, which can be used for assigning a character mesh. And the big thing here is that we have this character movements component. This character movement component contains really quite a lot of logic that handles humanoid character movement, as well as properties for changing the character's movement speed, the character's jump height, and it even applies gravity to the capsule component. When we start adding movement input to the character movement component is going to move the capsule components. It controls the root components for us. Now you'll notice that the components all say inherited by them. This is simply because when we create a new blueprint character class, we are inheriting from Unreal's character. We are creating a child of it to extend it by implementing our own logic and components. Now in the next lesson, we're going to start working with these components by assigning a character mesh as well as setting up our player camera. So we're going to wrap up this lesson here, and when you're ready, I'll see you in the next one. So we have our character class, but it doesn't really look like a character because we don't have a character model assigned to our mesh component. So let's take a look at fixing this. Let's come back to our content browser, and in the main content folder, we will see that we have a folder named characters. Inside this folder, we have another folder for the marine. So let's enter this folder, and we can see that we have 3 assets here. We're going to focus on the asset that's just named marine that has the pink thumbnail. This isn't a static mesh like what we've been working with in the previous sections. This is a skeletal mesh. Skeletal meshes are assets that have a skeleton, also known as a rig. Skeletal meshes can be animated. Now, we won't be creating the animations ourselves because that's a whole other area of development that would be handled by animators. However, our marine does come with animations that we can use. The animations drive the bones of the skeleton, and as a result, the bones move parts of the mesh. So let's open up our skeletal mesh asset for the marine so we can see him for the first time. So here we go, we are looking at the skeletal mesh asset here. And if you're opening this for the first time, it might take a moment to load, and it might also be compiling some shaders for you. So you might have to just wait a moment while the shaders compile, so feel free to pause here. Looking at the top right bar of this interface, we can switch between different tabs. We can select the animation tab to view the animations that come with this asset. And we can preview the different animations by double clicking on them in the asset viewer in the bottom right corner of the interface. So here we can see that the mesh isn't just static, but it gets animated. We can also view the skeleton for this character by switching over to the skeleton tab, and we can see a breakdown of all the individual bones of the character. And when we select a bone from this list, we see the bone highlighted in the character's mesh. Okay, so this is the character we're going to be using. We can close down all these tabs, and let's take a look at how we can assign him to our character blueprint. Let's come back to our marine blueprint. We want to assign the marine skeletal mesh to this mesh component slot. So let's select the component, and let's look towards the details panel. We can simply drop down the skeletal mesh slot to assign the marine character mesh that we just viewed. Now when we do this, the asset is not going to be in the correct place because the pivot point of the mesh component is in the center of the capsule component. So we're going to move this down. I'm going to bring it down to about 90 units here. And we can also see that the character is not facing forwards. This is where this arrow component comes in handy for us. So we want to rotate this character by 90 degrees so it faces the right way, the same way as this arrow. Okay, great. Now let's take a look at adding our own little touch to this character. With the character selected, we can see the character's material slot on the details panel. Let's hit this little magnifying glass so it takes us to where the material exists in our project. Instead of opening this material, we're going to take a look at creating a material instance from it. I'm attaching the material instance page from the Unreal Engine documentation as a resource to this lecture so you can read in depth about material instances in your own time. But the documentation tells us that material instances are used to change the appearance of a material without incurring an expensive recompilation of the material. Basically, this is telling us that we can edit parts of the material in real time without the need of the material having to compile, so we don't have to wait around for the shaders to compile. This marine material has parameters in it that can affect the color of the armor, the lights, and even the glass visor. By creating a material instance, these properties will be exposed for us so we can customize them. Let's take a look. We can create material instances by right-clicking on a material and then selecting Create Material Instance. You can name the material instance, and then once you do, you can open up the asset. Now the interface shows us a preview of the material, and it gives us a details panel where we can edit the material's parameters. However, this material preview isn't really showing us our material in context. We want to see it on our marine character. So to fix this, we can select the marine skeletal mesh from the content browser, and then inside the preview window of the material instance, we can select this teapot icon in the bottom right corner of the preview window to show us our material on the assets we have selected in the content browser. Now we are free to enable the parameters by clicking these checkboxes, and we can click on the colored bars to freely customize the exposed properties of this material. So I want you now to create a material instance for your marine and change the parameters of the material instance to create your own color scheme. So pause here to customize your marine's material. Okay, so here's the color scheme for my marine. I've gone for a blue color scheme with some green lighting on the emissive color. Now, if you actually open up the emissive color, you can make it glow more by increasing the number for this value here. The higher it is, the more it's going to glow. Okay, awesome. So we just need to assign this material instance to the character blueprint now. So we can select our character mesh, and we can change the material to use our material instance. Soon we'll be taking a look at making this character animated, but first let's move into the next lesson to dig into setting up the player camera and some movement input. Okay, so when we press play at the moment, we spawn, but we can't move or do anything because we don't have any logic in our character blueprint. We can also see that we are inside the mesh of our character at the moment. This is because our character blueprint doesn't have a camera component. So by default, Unreal will just set the camera to be at the center of the character. So let's just make sure that we add a camera component now. We're going to go for a top-down camera perspective. So let's open up our marine character and let's add a component, and it's going to be a spring arm, and we can just call this camera spring arm. And we can see that the spring arm is to the center of the character here. We can move it up a bit if we want to, but we're going to rotate this up, so it's not going to matter too much. Now we want to attach a camera to the camera spring arm, and the best way to do this is just by making sure that we have the camera spring arm selected, and we can add the camera component to make it a child of the spring arm. And as we can see, the camera attaches directly on the end of the spring arm there. So we're free to rotate the camera spring arm and change the target arm length to zoom the camera out a bit. And now if we hit compile and save and come back to the level and hit play, we can now see our marine character from our top-down perspective. Now, of course, he's not animated yet. We'll be coming to that shortly, but before we get to that, we first want to get him moving. And to get him moving, we're going to need some input axis events. So right now, I want you to pause here and add two input axis mappings to map the player movement input. The first input axis event is going to be used for moving the player character forwards and backwards, and the second is going to be used for moving the player character right and left. Once we have these input mappings, we can implement the events for them in our character blueprint, so we can start adding some movement input to the character. So pause here and add your two input axis mappings for the player movement. Okay, so to add to our input axis mappings, we're going to come up to Edit and then Project Settings. Then inside the project settings, we're going to come to the input section. And here is where we can add action mappings and axis mappings. We're going to add two axis mappings. One for moving forward, so this is going to be move forward. And moving forward is going to contain the axis values for moving forwards and backwards. And moving right is the next one. And that's going to contain the axis values for moving right and moving left. So to set up these axis values, we first need an input binding. So W is going to be for moving forwards on the keyboard, and then we can add in another axis map to this group, and this is going to be the S key. Let's scroll down till we find S, and we can change the scale here to -1. So when we hold down W, our axis value is going to be 1, and S is going to be -1. Now we're going to do the same for moving right, but right is going to be the D key. So let's find the D key, and then we're going to add another one for the A key for moving left, and the scale value here is going to be -1. Okay, so our input bindings are set up for our keyboard, but what if we have a gamepad like an Xbox controller or just a PC controller? Well, we can add some mappings to the same group for these as well. If we add in a new axis to the group, we can then come to gamepad, and we can scroll down till we find the left thumbstick here. So gamepad left thumbstick y-axis is going to be up and down, so we'll select this, and we can add one for moving right, and the moving right one is going to be the gamepad left thumbstick x-axis. Okay, and that is our axis mappings set up. So let's close our project settings. Now inside our marine character, we can come to the event graph, and within the event graph, we can call the events for our input axis mappings. So we can right click and search for move forward, and we want to make sure we select the axis event. And we can do the same for move right. If we right click, we can search for the axis event for move right. Now, how do we add movement to the character? Well, we can right click and we can come down to the pawn category, and then we can select the input section here, and here are some functions dealing with input. So we can look for the add movement input here. With add movement input, we can provide the movement direction and the scale value as well. So let's just move this function up a bit, and let's connect the execution pin from move forward into this function. And with the axis value of move forward, we're going to hook this up to the scale value. And the world direction that we want the player to move in is going to be 1 for the X. So this means when we press W or S, we're going to be moving along the X axis, either forwards or backwards. Now let's move the events for move right down, and let's duplicate the add movement input function with Control W to duplicate, and let's hook up the execution pin and connect the scale value just like before. But the world direction for this event is going to be on the y-axis. When we move right, we want to be moving along the y-axis. So we're going to use the value of 1. Okay, so this is our input setup for moving forwards and backwards. So we can hit compile and save. And now if we come back to the level and hit play, we can see that we can move forwards and backwards, and we can move left and right with the player character. Okay, so we're moving, but what's controlling our movement speed? Well, let's come back to our marine blueprint. Our character movement speed is actually coming from the character movements component. So if we select this and look towards the details panel and scroll down, we can come to the character movement walking category. And on here we have the max walk speed. So this is our movement speed. And if you want to adjust your character speed, you would do that here. Now, it's important to note that the character movement has nothing to do with the character model. You might think that you have an animation of the player running, and that's what makes the character move forwards, but it's not at all. The mesh actually has nothing to do with the character movement. What's happening when we use the add movement input function is we're running some code from the character movement component that basically moves our capsule around the world. It's the capsule that's moving, it's not the character model. The capsule is the root component that moves, and all the components attached to the root component move with it. So we want to start getting our character animated. So in the next lesson, we're going to be taking our first look at animation blueprints. So once you're ready, I'll see you there. So at the moment, we can press play, and we can move around as our character. But as we can see, the character isn't animated. So we're going to start taking our first steps for getting him animated in this lesson. We'll be starting with the basics. Now we already have animation assets for the marine character. We can see this by coming to characters, and then coming inside the marine folder, and then the animations folder. But how do we tie all these animations together to take into account our player character's movement? Well, we're going to be doing this inside a new type of blueprint we haven't seen yet, called an animation blueprint. And just like it says in the Unreal Engine documentation, an animation blueprint is a specialized blueprint that controls the animation of a skeletal mesh. So this is what we're going to be using to start putting together some logic behind these animations. Let's create the animation blueprint inside the folder where we have our animations. We're going to right click in the content browser and then come to animation and then the animation blueprint just here. Now when we do this, this window pops up and it has two sections. We don't need to worry about the top section of this window as it's not relevant to us at this stage. We just want to focus on this bottom half. It tells us to choose a target skeleton, which is going to be our marine skeleton here. So we just select the marine skeleton and then we can hit OK, and now we can name our animation blueprint asset in the content browser. So we can just name this something along the lines of anim bp_marine. Okay, so that's our animation blueprint asset created. Now let's double click on it to take our first look at it. Okay, so here we go. Straight away we can see a preview of our character on the left. This is going to update in response to the logic that we set up in our animation blueprint. Now the main thing to understand about animation blueprints is that you have these two tabs that kind of work like different contexts you work in. You have the anim graph and then you have the event graph. The anim graph is all about setting up animation state machines. This is where we'll be setting up the states such as the character being in an idle state or a running state, and the animation will switch depending on the state. The event graph is used for storing and updating variables that can then be used within the anim graph to drive the behavior of the state machines. But let's not get too lost at the moment. Let's start real simple by focusing on the anim graph. How do we get our character animating? He's currently in this static pose at the moment. Well, we see this big final animation result node, and it has this result connection to it in the form of this character icon. As there is nothing connected to the result, our character is stuck in his base pose. Now all those animation assets we saw can be used in this anim graph. If we look towards the bottom right corner of the interface, we can see this Asset Browser tab. Here we can see all the animations available for us that we can use in our anim graph. Let's click and drag out the idle animation onto the graph. And here we can see it's added a node for our animation, and it has this little character animation pose output pin. Now we can actually click and drag this and link it to the result of our final animation pose. Now it looks like nothing's happened, but take a look what happens when we hit compile. Our character is now in his idle animation. So this is a good first step for us. What happens now if we come back to our level and hit play? Well, we can see that the character is still in his base pose, even though we've just set up our animation blueprint, so he's in his idle animation. This is because our animation blueprint is not yet assigned to the mesh component of our marine character blueprint. So I want you to pause here and open up your marine blueprint and try find where you can assign the animation blueprint. Then assign it and hit play again, and you should see your character in his idle animation. Okay, so to assign our animation blueprint to our character mesh, we can select the mesh or select the mesh component, and on the details panel we can see that we have this animation section. We can drop down the anim class here and we can select our anim BP marine, and notice that the animation mode is set to use animation blueprint. We can switch this to use animation assets, so we can force the character into a particular animation, but we're going to use our animation blueprint here. And we can see our character is now animating already, and we can hit compile and save. And now when we hit play in the game, we can see he stood in his idle pose. Okay, great, but now when we move, he's still in his idle pose. So let's come back to our animation blueprint to take a look at how we can add some more animations. Now what happens if we want to have more than one animation? Well, this is where we want to start using a state machine. A state machine allows our animations to be broken up into user-defined states. We determine which state to go into with transition rules. For example, our character would only be in an idle state when he isn't moving, so the transition rule would check to see if the character's speed is equal to 0. When the character is moving throughout the world, we should be in the running state, so the running state would have a transition rule that would check to see if the character's speed is above 0. So let's take a look at how we can create a state machine in our anim graph. Let's start by deleting our idle animation, and if we right click, we can type into the search bar here, new state machine. So we can add a new state machine. Now when we select the state machine, we can add a name for it. We can just call this locomotion. This state machine is going to handle the locomotion of the character, so the idle and the running states. We can connect the animation pose from the state machine to the result of the final animation pose. But notice what happens here if we hit compile. Our character goes back into his base pose. This is because the state machine has no states within it and no animations inside of it. Let's double click on the state machine to enter it. Now we want to set up two states, one for our idle state that will contain the idle animation, and one for our running state that will contain the running animation. To add a new state, we can drag out from this entry node here and we can release. Then we can select Add New State. Now we can name the state. Our first state that we start with should be the idle state. So let's just name this idle. Now how do we assign the animation that the idle state has? Well, we can just double click on the idle state to enter it, and then we can drag and drop the animation in here just like before, and we can hook it up to the final pose for the state. Now let's come back to our state machine by coming up to this top bar and hitting the name of the state machine, or we can hit this back arrow towards the top left. Now let's add another state. To do this, we can drag out from the idle state and we can do the same thing as before. We can select Add New State and then we can name it, and this state is going to be our running state. So let's just name this running. And let's enter this state so we can assign the running animation. We're just going to use this run forward animation here. So let's make sure that we hook it up. Okay, and if we come back to our state machine again, we can see now that we have our idle state and our running state. And we also have this arrow connecting both of these states together. This is currently telling us that we can go from the idle state to the running state, but it's all based on the transition rule, which is why we have this little circle icon here. This is where we would set up the transition rule, but we can't really do anything with this yet because we need to work with some variables. And remember, we store and update variables within the event graph. So we're going to wrap this lesson here. In the next lesson, we're going to be working with the event graph so we can store and update some variables, so we can set up our transition rules for the state machine. So once you're ready, we'll be tackling this in the next lesson. Okay, so we have a state machine in our animation blueprint, and we have two states, our idle state and our running state. Now, in order to go from idle to running, we need to set up a transition rule. We need to tell the state machine to only go from idle to running when the player character is moving. But how do we even communicate to the player character to read information such as the character speed? Well, this is where the event graph comes in. In the event graph, we see this event called update animation, and this event will fire every frame. We're going to set up some blueprint code that will execute from this event. We want to calculate the speed of the player character, or more importantly, the pawn for which this animation blueprint is associated with. So how do we do this? Well, if we right click in the graph, we can come to animation, and then if we scroll down a bit, we can find the try get pawn owner function. This function returns a reference to a pawn, specifically the pawn that this animation blueprint is associated with. Now we need to narrow down if this pawn is our marine character blueprint. To do this, we need to look at casting. The character class inherits from a pawn. Then when we create a new blueprint character, we inherit from the character class. However, we could have numerous character classes across our project, and later in this section we will be building the aliens that attack the player as well, so we're going to have more than one character class. We currently only have a reference to a pawn. It's not a direct reference to our BP marine character class. However, by casting we can call properties and functions that relate only to the class that we want to work with. So let's drag out the return value of this function and let's cast it to our BP Marine character class. We can just start typing it out exactly how I say it. So cast to BP, and we can already see it here. So cast to BP Marine. Now let's make sure that we hook up the execution pin of our event blueprint update animation and connect this to the cast. Now we have the output execution pins of the cast node. This first execution pin will execute if the cast was successful. In other words, this pin will execute if the pawn that is associated with this animation blueprint is our BP Marine. So this is good because we will now be able to call properties and functions from our BP Marine character, something that will help us out a lot later. For now, we want to calculate the player speed. In order to do this, we're going to drag out from the return value pin here, which is the reference to the Marine character, and from this we can call a function to get the velocity of the character. And this returns a vector, but if we drag out the vector and call the vector length function from this, We will now have our character's speed as a float value. The speed is calculated as unreal units per second, just like the max walk speed on the character movement component. If we were stood idle, this value will be 0, and if we were running, this would be the same as the max walk speed of the character, which is by default 600 unreal units. So what do we want to do with this? Well, we want to promote it to a variable so we can store it and use it within our anim graph so we can drive our state machine. So let's right click on the return value of this function and promote it to a variable. And we can name this movement speed. Now let's just make sure that all our execution pins are hooked up correctly. So the event is hooked up to the cast, and then from the true output of the cast, if it is our marine blueprint, we're going to set our movement speed, and we can just move this set node up here as well and just move these functions just to make it a bit neater. So every frame, we're going to get the pawn owner and make sure it's the marine blueprint, and then if it is, we will store the character's movement speed. And now this is all we need to do in our event graph. Let's switch back over to our anim graph, which at the moment is our state machine actually, and notice that we have our movement speed variable now, and this is perfect because we can now correctly set up our transition rules for the states inside the state machine. Let's double click on this white circle here above the arrow that connects our idle state to the running state. This is where we can set up a condition to allow us to go from our idle state to our running state. This is going to be rather simple to do. To go from idle to running, we want to make sure that the character's speed is over 0. So we can simply drag our movement speed variable off the variables tab onto the graph and we can get it. And if we pull out the pin for the variable, we can then put in the greater than symbol and we can call float greater than float. Now we don't even need to change the value. This is asking a question: is the character movement speed above 0? And the answer to the question is going to be stored in this Boolean return value. And we can plug this straight into the can enter transition result. So the answer to our question will determine if we can go from idle to running. So if the movement speed is above 0, we can now enter the running transition. So let's just hit compile and save to save our work. And if we come back to our level and hit play, we can see that the character is in the idle animation, but as soon as we start running forwards, the character is now in his running animation. But as soon as we stop, we then get stuck in the running animation. So this is because we haven't set up the transition to go from running back to idle. But I want you to do this. Connect the running state to the idle state. This will then create a new transition rule. To transition from running to idle, you want to check if the movement speed is equal to 0. So pause here to set up this second transition rule. Okay, so to set up this transition to go from running back to idle, we first want to drag from the running state back to the idle state and we can connect it so we can create a new transition rule. We can double click on the white circle to set up the transition rule now. To go from running back to idle, we want to get our movement speed variable and we want to check to see if the movement speed is equal to 0. So we're going to drag out the pin, we can put in the equals symbol, and we can just get a equal float. So is this float equal to 0? The answer to this will determine if we can enter the idle state from the running state. Okay, let's hit compile and save. And let's come back and just look at our state machine. So we can go from idle to running, but we can also go from running back to idle as well. Now if we come back to our level and hit play, we can see we are stood idle. As soon as we start moving forwards, we go into our running animation, and as soon as we stop, we then go back into our idle animation. Awesome, so this is working pretty well, but you'll notice if we run right or left or backwards, we are still in our running forwards animation. But we have other animations for running in different directions. So let's see how we can set those up in the next lesson. Okay, so at the moment when we play our game, our character is in his idle animation, and when we add input, we cause our character to move, and he goes into his running animation. This is due to the fact that our state machine is now aware of our character's movement speed. It toggles between the idle and running states depending on the character's movement. However, we want it to make it so the character will blend between the different running animations we have depending on our character's movement direction. To do this, we're going to be creating a blend space. A blend space is an animation asset in Unreal that we can use to blend between multiple different animations. Blend spaces have their own axis values, which are used to control how we blend between the animations of the blend space. Let's take a look. To create a blend space, let's find the folder where we have our marine animations. And let's right click in this folder and come to animation. And here we can see the animation assets we can create. One of them is a blend space. We also see a blend space 1D here. When we hover over a blend space, it says it contains a grid of data points with weights from sample points in the space. So it's a bit of a complex explanation for this. Let's just create a regular blend space here and take a look at it. First, we have to pick a skeleton that we want the blend space to be associated with. We want it to be associated with the marine skeleton. So what do we want to call the blend space? Well, let's just call this movement blend space. And let's double click on the asset to open it. Here's our first look at a blend space. We see along the bottom center of the interface, we have this graph. And this graph has a vertical axis and a horizontal axis that we plot animations on. In our case, the vertical axis is going to be our character movement speed, and the horizontal axis is going to be the character's movement direction. When we plot animations onto the graph, we're going to be able to see how the animations will blend depending on the character's speed and the character's movement direction. All of this will be driven by variables inside our state machine. All we have to focus on here is setting up our axis values and plotting our animations onto this graph. So how do we customize the horizontal axis and the vertical axis? Well, if we look on the Asset Details panel, we see we have the axis settings, and we can expand each axis for more details here. We can see we can provide the axis name and the minimum axis value and also the maximum axis value. So for the horizontal axis, the name is going to be movement direction. For the vertical axis, the name is going to be movement speed. And we can see that the axis names have been updated on the graph after we hit enter. Our movement speed is going to go between 0 and the maximum movement speed of our character, which is the max walk speed on the character movement component. So for me, that's going to be 600. And our movement direction is going to go between negative 180 to positive 180. Okay, now that's our axis values set up. We can see they are named correctly and they have their value ranges applied. Now we just need to plot our animations onto the graph. We can drag and drop animations onto the graph from the asset browser. But what animations do we want to use here and where do we plot them onto the graph? Well, let's look at the value ranges. 0 movement direction and 0 movement speed is going to be plotted here. So what happens if we're not moving and we're not moving in any direction? Well, we should be playing the idle animation. So let's click and drag the idle animation and drag it onto the bottom of the graph here. Now what happens if our movement speed is 0 and the movement direction is 90 degrees? Well, we're still going to be in the idle animation because we have 0 movement speed. In fact, the whole bottom section of this graph represents our movement speed being 0, so we're going to plot our idle animation all along the bottom here. Now the top of our graph represents our character moving, so if we are moving and we are moving at 0 degrees, we should be running forwards. But if we are moving and we are moving at 90 degrees, we could be using the run right animation. And if we are running at negative 90 degrees, we could be running left. And if we are running at 180 degrees or negative 180 degrees, this will both be the run backward animation, so we can plot these here as well. Now we can preview our blend space by holding down the left shift key and dragging our mouse around. So all along the bottom is where we are idle, but if we start moving, we can see how we would blend to our run forwards animation. And then if we started to change our movement direction to 90 degrees, we would see that the animation would blend to the running right animation. And we can see how this would work for all the different movement direction values. Okay, so this is how our blend space is going to work. And we're going to drive these values here with some variables in our animation blueprint. So let's save this asset and let's close it and let's come back to our animation blueprint. The first thing we want to do is make sure that we're calculating the movement direction of the player character. Now this sounds a bit scary, but it's quite simple to do because Unreal already has a function for this. So make sure you're inside the event graph, and just to let you know, if you accidentally close the event graph or the anim graph, you can double click on either one inside the My Blueprint tab to bring them back. So inside the event graph, to calculate the direction of the player's movement, we can right click and we can come to animation, and the first function here is called calculate direction. We can hook this up to the execution flow, and we can see that we have two inputs here, velocity and base rotation. Well, we're already getting the velocity here, so let's click and drag from the return value and plug it in to the calculate direction. And now for the base rotation, we can simply use the actor rotation of our marine. So let's drag out from the pin from the cast and get the actor rotation. And we can use the return value from this for our base rotation. Now we need to store this direction just like we do when we calculate the movement speed. So let's right click on the return value here and promote it to a variable named movement direction. Okay, and that is our movement direction calculated. Now our blueprint is looking a tiny bit messy here, so let's take a look at cleaning this up. Instead of getting the pawn owner and casting to our marine every frame, we're going to store a reference to our marine from the begin play event. So in an empty space, let's right click and come to add event, and let's select the event blueprint begin play. And let's duplicate the try get pawn owner and the cast up to our begin play event. So on begin play, we get the pawn owner and check to see if it's our marine. Now what can we do with this? Well, we can promote the reference pin to a variable, and we can just call this marine. Now this allows us to remove our try get pawn owner and cast to the marine off the tick here, and we can grab our marine and throw it into the target for the get velocity, and we can grab it again and throw it into the target for the get actor rotation, and we can space these nodes out a bit to show that they are doing two different things here, and we can even break the velocity link and call get velocity on this instance of our variable. So this is our calculate movement direction, and this is our calculate movement speed. Now it's important to note that when dealing with references to actors, you have to check if they are valid, or sometimes you'll play and then when you stop playing you'll see some errors pop up saying that the reference isn't valid. This is because the reference might not be set. So to fix this, we first want to get our marine, and we want to check if it's valid, and we can do this by calling the isValid macro. So every frame we'll check to see if the marine is valid, and if he is valid we'll calculate his movement speed, and then we will calculate the movement direction. And right now I just want you to pause here to collapse your code into functions where you calculate your movement speed and your movement direction. Okay, so we can start by collapsing our calculate movement speed down into a function, and we can simply call it the same name, calculate movement speed. And let's move that over there. And then with our calculate direction, we can right click on this and collapse this to a function called calculate movement direction. And we can bring this over here as well. And we can get rid of these errors just by hitting compile. It's always important to take your time to write clean, readable blueprint code. It's a good habit to get into early on. If you come back to this code later, or if we start to add more to it at any time, we'll be able to clearly understand what does what. It's so easy to just say, oh, I'll just clean this up later and then never do it. But let's always make sure that we make our code clean and readable first before moving on to something else. Now we calculate our movement speed and we calculate our movement direction that can be used for our blend space. So let's switch over to our anim graph and let's enter our locomotion state machine. And we're going to change our states here. Our idle state is going to become the single state for our movement blend space. To rename it, we can select it and we can hit F2 to rename. And we're not even going to need our running state, but we will be adding another state later in this course when we set up our sprint ability. But with our movement blend space, we can enter the state, and instead of it playing idle, we can remove this. We can come to our asset browser and we can see we have our movement blend space here. We can click and drag it onto the graph and we can hook it up to the result. And look, we have some input pins for our movement direction and movement speed. These are the horizontal axis and the vertical axis that we set up. So let's connect our movement speed to the input here, and the same for the movement direction. So our variables are going to be driving the axis values of our blend space now. So let's hit compile and save. and close our animation blueprint and come and play the game and see what happens now. So we're in our idle animation, and if we start moving in different directions, we can see that the animations are changing depending on our movement direction. So our blend space is now working correctly. So this is really good progress. We have our character class moving and we have the mesh animating and responding to our movement. The next step for our character is to get him to turn. We're going to make the character turn towards the direction that we want him to fire. So we're going to start working on this in the next lesson. So we want to start setting up the aiming for our character, and in this section we're going to be setting up both mouse aiming and thumbstick aiming for gamepads. We're going to start with the thumbstick aiming. I've got my gamepad plugged in and I can hit play and move my character around with the left thumbstick because we bound the left thumbstick to our input axis mapping for moving forwards and moving right. But when we turn the right thumbstick, we're going to make the character face the direction that we're turning our thumbstick in. So to begin with this, we're going to create some axis mappings for our thumbstick aiming. So let's come up to Edit, and then Project Settings. And let's come to the Input section so we can add in two new axis mappings. The first is going to be called Thumbstick Aim Up, and the second is going to be called Thumbstick Aim Right. For the thumbstick aim up, we're going to bind the gamepad right thumbstick y-axis for this. So that's going to be moving the thumbstick up and down. And for moving the thumbstick right and left, we're going to bind this to the thumbstick aim right axis mapping, which is going to be gamepad right thumbstick x-axis. Okay, so this is our input mapping setup for the gamepad. Let's close the project settings and come back to our marine blueprint. So how are we going to translate the right thumbstick into actually rotating our character? Well, we're going to start writing a function that's going to be executed from our tick event. Let's create a new function called update player aim. Let's come back to our event graph and make sure that we execute this from our tick event. Now let's double click on our function so we can start writing some blueprints code for it. First, we must understand that the player controller has its own rotation that the pawn will listen to by default for aiming and rotating. What do I mean by this? Well, if we select the Class Defaults button on the top toolbar, we can see on the Details panel we have this pawn section, and here it's telling us that by default it's going to use the controller rotation yaw. So what does this mean? If we hover over this, it says if true, this pawn's yaw will be updated to match the controller's control rotation yaw if controlled by a player controller. The player controller has its own rotator in its class called control rotation. This control rotation is used by pawns for dealing with things such as rotating and aiming. So to rotate our character, we're going to want to affect the control rotation of the player controller. So inside our update player aim function, we're going to get the player controller and we're going to set the control rotation of the player controller. To do this, we're going to drag out from the return value and call the set control rotation function. We're going to hook this up to the execution pin, and here we have a new rotation. So we have this rotator pin. We're going to drag this out and just type in make rotator. So now we have access to the roll, pitch, and yaw values. And remember, the pitch and the roll aren't checked on the class defaults. So by default, our character is going to ignore the roll and pitch values. But this is fine because we only care about the yaw. The yaw will turn our player character. For now, let's just hard code the yaw in as 135 for now. This should mean that when we play the game, our character will be rotated by 135 degrees. So let's try this. Let's come back to our level and hit play. So we can actually see that our character has rotated now, but we have an issue here. The character is rotating, but so is the camera as well. We don't want the camera to rotate when the character rotates. And I want you to try and fix this now. Pause here and stop our camera from rotating whenever we rotate the character. Don't worry if you can't remember exactly how to do this, I'll show you again in a moment, but pause here and see if you can remember. So to fix our camera from rotating when the character rotates, we want to be looking towards the components of our marine blueprint. It's all because of our spring arm. Our spring arm is always going to try maintain its relative rotation to the root component. So when the character rotates, the spring arm rotates with it. But we can override this by selecting the spring arm, and on the details panel where we have the transform section, we can drop down rotation, and we can see here that it's set to use relative rotation, but we can change this to world rotation, so the spring arm will completely ignore the rotation of our character. Now if we come back to our level and hit play, we can see our character is rotated by 135 degrees, but the camera hasn't rotated with it. Awesome. Now there's something we should make ourselves aware of here. Our camera is always going to be facing along the x-axis of our level, and the same goes for our movement. If we push up on the thumbstick or press W, the character will move positively along the x-axis. Just be aware of this if you go off and design any levels. If you rotate your player start, the controls might seem a bit funky, but you can always use this little widget in our viewport showing us the directions for each axis, and we can visualize here which is the forward facing direction of our level by looking at the X direction. Now let's come back to our marine blueprint and back to our update player aim function so we can continue setting up our thumbstick aim. I'm just going to move our nodes along here just so we can make a bit more space to write our code. So we're going to start by getting our thumbstick aim axis values, so thumbstick aim up, and we're also going to get thumbstick aim right. Now before moving any further, let's visualize what we're going to be doing here. When we push the right thumbstick up or down, our aim up axis value is going to be between the range of -1 and 1. And if we push the thumbstick right or left, our aim right axis value is going to be between the range of -1 and 1 as well. We somehow need to convert these values to an angle, so we can use it as the yaw value for setting our control rotation. Now we're not going to be diving really deep into the math behind this, but to help us convert our axis values to an angle, we're going to use a function called atan 2 degrees. This function is going to return the arc tangent of the two numbers we provide, and the results we get from this function will be an angle. Imagine we've just pushed the right thumbstick diagonally up to the right. The axis values for aim up and aim right would both be 0.5. If we pass these into the atan 2 degrees function, we would get the result we need as an angle. Let's just start printing out these values of this function to our screen so we can see how our input affects it. Let's right click and search for atan. We can see different functions here. We're going to use the one named atan 2 degrees. So we can plug our thumbstick aim up into the A input, and then we can plug the thumbstick aim right into the B input. Now instead of plugging this straight into our make rotator node, we're going to print these values so we can see what's happening. So let's call the print string function, and let's make sure we hook up the execution pins here. And let's print out the return value of our atan 2 degrees function. Now let's come back to our level and hit play. So without pushing the thumbstick, we get 0. Okay, but if we start pushing the thumbstick up, it's giving us a value of -90. As we start to move the thumbstick towards the right, we get 0. And when we push it down, we get 90. And then when we push it left, we get 180. So let's just visualize this quickly. So currently, up is -90 degrees and down is 90 degrees. Right is 0 degrees and left is 180 degrees. It's actually almost there. This is very close. It's just our A and B inputs need to be reversed for us on the atan 2 function. To fix this, let's use aim right as the A input and aim up as the B input. So now let's see what happens. When we push up, we get 180, and when we push right, we get 90 now, which is actually correct. When we push down, we get 0, and when we push left, we get -90, which is also correct, which is what we want. But 180 and 0 for pushing up and down is wrong. This is because these are inverted. We just need to invert our scale value for our aim up input axis mapping. So now if we play the game and push up, we get 0 degrees, which is correct. We get 90 for right, we get 180 for down, and we get -90 for left. So this is actually looking really good. Let's come back to our function, and let's connect the return value now directly into the yaw input of the make rotator. Let's compile and save for the final time for this lesson, and let's try again. Now if we turn, we can see our character is facing the direction that we push our thumbstick in. Awesome, so this is working really well, and we can even run around the level and push the thumbstick and the character will still face towards the direction that we're looking in, independent of our movement. But we do have an issue here. You'll notice that if you release the thumbstick, your character will snap back up to 0 degrees. It will snap back up to aiming forwards. So we're going to be fixing this up in the next lesson by creating a thumbstick dead zone. So once you're ready, I'll see you in the next lesson. Okay, so at the moment we have an issue with our thumbstick aim. We can push the right thumbstick in a direction and we can make the character face the direction that we're pushing the thumbstick in, which is great, but at the moment when we release the thumbstick, our character will always snap back to facing forwards. Now we want to prevent the character from doing this when we release the thumbstick, and the solution to this is to set up a thumbstick dead zone. Currently, we rotate the character based on our thumbstick input, but we only want to rotate the character when these thumbstick input values are large enough. When I say thumbstick dead zone, I really just mean a range in which our thumbstick input is ignored. So we're only going to rotate the character when the values of our thumbstick input are large enough or high enough, and if they are too low, we won't even bother calling the function that rotates our character. So how do we get started here? Well, we're going to open up our Marine blueprint, and inside our update player aim function, we can actually remove the print string and the float to string conversion here. Let's just make sure that we hook up our execution pin again to the set control rotation function. Now we're going to proceed by creating a new function, and this function is going to check if our thumbstick input values are above the thumbstick dead zone. So we can name this is thumbstick above dead zone. And we're going to start by calling our thumbstick aim up axis value, and we're also going to get the thumbstick aim right axis value. Now what are we going to do with both of these values? Well, we're going to make a vector, and it's going to be a vector 2D. The aim up is going to be the x value, and the aim right is going to be the y value. Now a vector 2D doesn't have a z value here, so we're just working with x and y. With the return value of our vector 2D, we're going to drag this out, and we're going to call the vector length function. We're going to grab the vector 2D length here. So this returns the length of our vector. Now feel free to print the return value of our 2D vector length function as a string, just like I'm doing here. And as we can see, when we don't push on the thumbstick, the length of our 2D vector is going to return 0. But as we push the thumbstick in any direction, the value returned is going to be 1 or above. And if we gently release the thumbstick, we can start to see that the values decrease all the way down to 0. And the 0 is where our issues come in. If we push right on the thumbstick, the character faces the right direction, and as we gently release, we can see that he still faces the correct direction, but as soon as we hit 0, the character snaps back to facing forwards. And this happens in any direction as well. We're only going to allow our character to rotate if the length of our 2D vector is over a particular value. So we're going to compare the length of the vector to another float. By doing this, we are making our own thumbstick dead zone. And I want you to try finish off our function by yourself. So I want you to create a variable named thumbstick deadzone, make it a float, and give it a default value of 0.5. Now we're already getting the length of the 2D vector we just made in our function. We want to do a comparison with this. We want to compare the length of the 2D vector to see if it's greater than the thumbstick deadzone. Once you've got this far, we're not going to write any more code in this function. Instead, we're just going to return the result of this comparison as an output pin on the function. So I want you to do this as well. And just to wrap it up, look over the code for the function, check the function name, look at what it's doing. Should the function be impure, pure, or pure const? So pause here for a few minutes to set up the rest of this function. Okay, so with the length of our 2D vector, we can compare it to see if it's greater than a value by dragging it out and putting in the greater than symbol, and we can get the float greater than float. Now, what do we want to compare it to? Well, we want to compare it to a value that will be our thumbstick dead zone, which we currently don't have. So we're going to create it. Let's create a new variable named thumbstick deadzone, and let's change the variable type from a boolean to a float. Now we can hit compile to set the default value, which is going to be 0.5. And we can plug it straight into the second input on this comparison here. So this now asks the question, is the thumbstick input greater than the thumbstick dead zone? And the answer to this will be returned in this boolean pin here. We want to output this on our function, but there's no return node inside our function here. To get one, we can right click and scroll all the way down, and we can find this add return node selection here. And if we select this, it adds the return node. And we can drag and drop our boolean onto the return node to create a return value. And we can hook up our execution pin. And this is our function, or the code for our function, complete. But now comes the question, should this function be impure, pure, or pure const? Well, by looking at the name of this function, we can see it's named is thumbstick above dead zone. We can tell that it's named in a way that's stating its intention. It's asking a question or doing a calculation. So just by looking at the name, we should be thinking that this function isn't going to affect the state of our blueprint class in any way. But also by looking at the code of our function, we can see that there's not much going on in terms of the execution flow. It's certainly not setting anything or affecting anything in the world. Therefore, our function can be pure, const. We ask the question, is the thumbstick above the dead zone, and the function gives us the answer. Now this is our function complete. We can compile, and we can close this tab because we don't need to change any of the code for this anymore, and we can come back to our update player aim function. Now we said that we only want to change the rotation of the character, and remember we do this by setting the control rotation of the player controller. We only want to change the rotation if our thumbstick is above the dead zone. So we're going to call our is thumbstick above dead zone function that we just wrote. We can drag it onto the graph. We can hold down B and left click to place a branch on the graph. We can use our function as the condition. We can hook up the execution pin to this. So we can see, is the thumbstick above the dead zone? If it is, we can then set the control rotation for the character. Awesome, so let's hit compile and let's save. Let's come back to our level and let's try this. The character faces forwards with no input on the right thumbstick, but we can push the right thumbstick in the direction that we want the character to turn. But if we release the thumbstick now, the character no longer snaps back forwards. So the thumbstick aiming is now working correctly. Awesome, this is really good progress. Now there's not actually anything more we need to do in terms of the thumbstick aiming, but we do want to start thinking about mouse and keyboard input. So we're going to start tackling this in the next lesson. Hey, and welcome to this lesson where we're going to make our character aim in the direction that we move our mouse in. We're already doing this with the gamepad, but we want to make our game playable for those playing with mouse and keyboard. Now, our mouse isn't like a gamepad. On a gamepad, we can hold a thumbstick in one direction, but to get the same result with a mouse, we would have to continuously move a mouse in a direction to get the same result as pushing a thumbstick. So we're going to have to write some slightly different code for handling the mouse aiming for our character. So we're going to disable the thumbstick aiming code we wrote in the previous lesson, just for now while we start writing the code that relates to our mouse aiming. Then we'll see in the next lesson how we can combine both the mouse and gamepad aiming together. But our objectives for this lesson are to create a function that returns the mouse velocity, and we want to create a mouse dead zone, similar to how we created a dead zone for the right thumbstick. Then we only want to rotate our marine if the mouse is over the dead zone. So we're going to be working inside the update player aim function within our marine blueprint. And we want to start by breaking off our thumbstick aiming code. Remember, we can break off execution pins by hovering over a pin and holding down left alt and then left clicking on the pin. Now we can move all of these nodes down that handle our thumbstick aiming. We'll come back to these in the next lesson. Now we're going to create a new pure const function. So let's hit new function and we're going to name it get mouse velocity. Let's also mark it as pure and as const. And let's just make sure that we hit compile before we start writing our code. We need to start by determining how far the mouse has moved in this frame compared to the previous frame. There's a function that already does this inside the player controller that we can call. So let's get the player controller, and let's drag out from the player controller to call a function named getInputMouseDelta. When we hover over this node, it tells us that it returns how far the mouse has moved in this frame. And we can see it returns an X and a Y value. So it tells us how far up and down or left and right our mouse has moved. We're going to proceed by making this into a 2D vector. We can right click and call makeVector2D, and then we can plug the delta X into the X input, and then we can plug the delta Y into the Y input. Now to get our velocity, we need to divide this distance the mouse has moved by the time that has passed since the last frame. We're going to drag out from our vector 2D and put in a division symbol so we can divide the vector 2D. We're going to divide it by a float. So I said we want to divide it by the time that has passed since the last frame. And we can call a function that will return this value as a float. It's called getWorldDeltaSeconds. This is what we're going to use to divide our 2D vector by. Now the output pin of this division is going to contain the mouse velocity. The final step for our function is to make sure that the function returns this value. So we're going to right click and either scroll down or just type in add return node. We can drag the pin onto the return node to make it return this value. Then we just need to hook up the execution pin, and then we can hit compile and save, and this is our get mouse velocity function complete. So we've disabled the thumbstick aiming, and we've completed the first objective of setting up our mouse aiming by creating a function that calculates the mouse velocity. This is going to help us create a mouse dead zone. But before we create a mouse dead zone, let's start setting up the code that rotates our character. Let's come back to our update player aim function. We already know how to rotate the character. We have to adjust the control rotation of the player controller. So let's do this. Let's get the player controller, and then let's call set control rotation from the player controller. And let's hook up the execution pin here. Now remember, we don't want to adjust the pitch and roll of the control rotation. We're going to take the rotator input pin and drag it out and call make rotator. This now gives us access to the roll, pitch and yaw. We're going to leave the roll and pitch at 0, and then we're only going to adjust the yaw value. The yaw is what we use for turning the character. So how do we go about calculating the aim direction when we use the mouse? Well, it's kind of going to be similar to what we did with the thumbstick aiming. We made use of this 8 and 2 degrees node, and we're going to use this again. But instead of getting the input values like we do with the thumbstick, we're going to make use of the mouse velocity node we just wrote. Take note that after you create a function, you can search for them in the action menu like any other function. So I'm going to bring up the action menu and call the getMouseVelocity function we just wrote. And we're also going to call the ATAN2 function, and we want to use the version that uses degrees. We can split our mouse velocity to gain access to the X and Y values that can be used for the A and B input on the ATAN2 function. Then we can drive the yaw rotation of our character with the return value. The ATAN2 function will read the mouse velocity and calculate the angle that we want our character to face. Okay, so you'll notice that it's kind of similar to how we set up the thumbstick, but let's save our work and let's come back to our level and see how this is progressing. You'll notice that it's very snappy, and you'll have to continuously pan the mouse to make the character face a particular direction. As soon as you stop panning the mouse, the character snaps back to facing forwards. It's the same issue we had with the thumbstick. As soon as we stop our input, the character faces forwards. In order to fix this, I'm going to challenge you to set up a mouse dead zone. Create a float variable for your mouse dead zone. You can tweak and tune it however you want, but for a good starting default value, I'd recommend using 20. Then create a function that will be used to check if the mouse is above the mouse dead zone. Make sure to check that it's pure const, and then inside the function, you want to compare the length of the mouse velocity to your mouse dead zone variable. Check if the length of the mouse velocity vector is greater than the mouse dead zone, and return the Boolean result of the comparison as an output pin on the function. Then for the final step, with your function complete, rotate the marine only if the mouse is above the dead zone. So pause here and follow the challenge, and remember, if you get stuck, you can always check your thumbstick aiming code. Okay, so I hope you had a go at the challenge. You should now have a new pure const function in your marine blueprint that calculates if the mouse input is above the mouse dead zone. We do this by getting the vector length of the mouse velocity, then we compare it to a new variable that I've named mouse dead zone, and this has a default value of 20. We return the result of this comparison as an output pin on our function. So inside our update player aim function, we can now check if the mouse input is above the mouse dead zone. And if it is, we then go on and set the yaw control rotation of the player controller. So now if we come back to our level and play our game, we will notice that the character will no longer snap back to facing forwards when we stop moving the mouse. However, we do have an issue here. The mouse feels very snappy. It feels pretty much unusable at this point because it's way too sensitive. So to fix this, and this will be our final step for setting up the mouse aim, we're going to apply some mouse smoothing. To apply mouse smoothing, we're going to do some interpolation. Inside the Blueprint Action menu, we can find the Math category, and within Math, we can find the Interpolation category. Now, there's many different nodes here for interpolating different types of data, but we're going to be interpolating from one rotator to another. The node we're going to use is called rinterp2. This function will simply smooth the values of one rotator to another. And this node will have to be used on tick, which is fine because our update player aim function is called on tick. But I just want to be clear that this function wouldn't work as expected if it wasn't called every frame. We just have to provide the world delta seconds and how fast we want the smoothing to be. So inside our update player aim function, instead of just setting the control rotation with our mouse aim calculation here, we're going to break off the make rotator and move all of this down a bit. And we're also just going to move these other two nodes along a little. Now with the player controller, we're going to get the control rotation. So every frame, we will know what the current rotation of the character is, and then we want to smooth this to the result of our mouse aim direction. To do this, we can drag out from the new rotation pin on the set control rotation function, and we can come to the math category, and then the interpolation category, and we can grab the rinterp2 function. So we want to interpolate from our control rotation to our mouse aim direction every frame. Let's just move these nodes a bit closer. Now for the next pin, we have the delta time. We can use the get world delta seconds function for the delta time input. And the interp speed is going to control how fast the smoothing is going to be. The higher the value, the faster the smoothing, and the lower the value, the slower the smoothing will be. But we're not going to hard code in a value here. We might want to easily tune this, so we're going to promote this pin to a variable. We're going to call this mouse smoothing strength. When we compile, we can set the default value of this variable. I'm going to use the value of 7, but you can tweak this as you need to until you feel comfortable with your mouse smoothing. Now let's compile and save our work for the final time for this lesson. And this is all our code for our mouse aiming, including the mouse smoothing. It's a bit messy, but we'll be cleaning up all of this in the next lesson when we combine the mouse and the thumbstick aiming together. But for now, let's come back to our level and let's see the result of what we've got. Okay, so this is feeling way more comfortable with the mouse now. It's no longer extremely sensitive, and the character is moving towards the mouse aim direction. Awesome, so our mouse aiming is working great now. We just need to clean up our code and find a way to toggle between mouse input or gamepad input for the aiming. So we'll be tackling all of this in the next lesson. Okay, so inside our Marine blueprint, we have our update player aim function. Now this function contains code that rotates the player depending on our mouse input, and it also contains code that rotates the player depending on the gamepad right thumbstick input. Now we can't just execute all of this code at once because the mouse input will fight against the thumbstick input. So we need a way to ignore the mouse aiming if we are using the gamepad, and we need a way to ignore the gamepad input if we are using the mouse. We really need to understand which input the player is currently using. We'll get to this really soon, but first, let's just clean up the code we already have, as this will make the next step much easier. Remember, we always want our code to be easily readable, so if we come back to it at any time, we can clearly understand what's going on. So let's start with the nodes that are already hooked up to this function. This handles our mouse aiming. Let's select all of these nodes and let's encapsulate them down into a function by right-clicking on them and coming to collapse the function. We're going to name this update mouse aim. Now with all the functions we're going to write here, we can select them and let's put them into a category. So this is going to go into a category named mouse input. And we can also put any of the other functions that relate to our mouse input into this category as well. So get mouse velocity, we can drop down the category for it and put it into mouse input. And the same for is mouse above dead zone. Now already this is looking a bit clearer, but we can still clean up the blueprint code inside this function. So let's double click on it to enter it. Let's just move this function entry node up a little. Now the start of this function reads okay. If the mouse is above the dead zone, continue on and execute the next block of code. But all of these nodes can definitely be cleared up here. First, I'm going to break the link on the player controller and move this down. And I'm just going to set this as the target for get control rotation. Now, why have I done this? Well, when we collapse all of these nodes here down into a function, we won't have to have the get player controller as an input pin on the function. So let's right click on these nodes and let's collapse these down to a function named get mouse aim direction. And we want this function to be a pure const function, and we can put it into our mouse inputs category. And we can just move these nodes up and move these back. And remember, we want to use the player controller as the target of our set control rotation function. Okay, great. So this is much easier to understand now. It's a lot easier to read. So we're finished here. We can close this tab to come back to the main update player aim function. So this just executes our update mouse aim, but remember we also have all of this code down here that handles the thumbstick aiming. This can all be cleared up as well, but I want you to clear this code up. Collapse your thumbstick aiming code into functions, just like how we've done with the mouse. Think carefully about using impure or pure const functions, then make sure that any functions you do create are added into a new category named thumbstick input. So pause here to clean up your thumbstick aiming code. Okay, so inside my update player aim function, I've cleaned up all the code that handles the thumbstick aiming. It's all contained in an impure function, just like the mouse aim. We are using impure functions for these because inside these functions, we are setting the control rotation of the player controller. We are changing the state of it. I've also collapsed all the code where we calculate the thumbstick aim direction down into a pure const function as well. Now all of these functions are in their relevant categories. We can also put variables in categories too. So the Thumbstick Deadzone can go into a category named Thumbstick Input, and Mouse Deadzone can go into the Mouse Inputs category, and Mouse Moving Strength can also go into the Mouse Inputs category. Awesome, so now inside our update player aim function, we are just left with the functions that handle the mouse aiming and the thumbstick aiming. Now we need a way to determine if the player is using the mouse or the gamepad and then switch which function to execute accordingly. So to do this, we can come back to our events graph, but we're going to close all the tabs for our functions so we don't get confused here. Now we're going to come over to an empty space in our event graph. We're going to right click to bring up the action menu. We know that we can call input events to get keys and gamepad buttons, but we can also call an event that will execute whenever any key or button is pressed. This event is called anyKey. So let's get the anyKey event. We can see it has output execution pins for when any key is pressed or any key is released. Now it's called anyKey, but it will also execute for mouse buttons or gamepad buttons as well. We also have this key output pin here. Now what can we do with this? Well, we can drag it out, and there are input functions we can call to check to see what kind of key was pressed. We can type is keyboard key, which will return a boolean with the result of if the input came from a keyboard. And we can get a similar function for the mouse. It's called is mouse button. And we can also get one for the gamepad. It's just called is gamepad key. Now your final challenge for this lesson is to create a boolean variable that stores if the gamepad is active. You can determine this with the anyKey event. Then you want to use this boolean inside your update player aim function. Call update thumbstick aim if the gamepad is active. If it's not active, call the update mouse aim function. So pause here to attempt this challenge, and then we can wrap up this lesson. Okay, so to determine if the gamepad is active, whenever any key is pressed, we can check to see if it's a gamepad key. We can simply store the return value as a boolean named gamepad active. And we want to set this whenever any key is pressed. So whenever any key is pressed, we store if it's the gamepad. If it's a gamepad button, then we will know that the gamepad is active. Now this allows us to come back up to our update player aim function that we call from our tick event. And inside this function, we can get our gamepad active variable. And we can move these nodes along here. I'm going to break the link here and hold down B to add a branch. We're going to hook up the entry node to the branch, use the gamepad active as the condition. So if the gamepad is active, we will then update the thumbstick aim. And if the gamepad isn't active, then we must be using the mouse. Awesome, so we're now switching the input depending on if we're using a gamepad or not. We can hit compile and save for the final time for this lesson, and we can come back to our level to play the game. So I can use the mouse to turn around, and as soon as I switch to my controller, I can move and aim with the controller as well. Awesome, so we now have mouse input and gamepad input working without any of them fighting. So let's move straight on to the next lesson so we can start looking into how we're going to handle the player's weapon. So once you're ready, I'll see you there. Okay, so currently our Marine has no weapon in his hands. In this lesson, we're going to give him a weapon, and we're also going to spawn some effects when the weapon is fired. Inside our project, in the content browser, we can see we have a weapons folder. We have a skeletal mesh here for a rifle. So remember, this is just a mesh. It doesn't have any sort of behavior. Unreal has no concept of it even being a weapon. We're going to be coding all the weapon behavior in blueprints. With the mesh open, we can see its material slots on the asset details panel, and these are material instances. So we can open these and we can pull the tab off here so we can see the mesh at the same time as our material instance window. And we can adjust the parameters for the material to customize how the weapon looks. So an early challenge for you in this lesson, open the material instances for the rifle and adjust the parameters to customize your Marine's weapon. Then once you've done this, head over to your Marine blueprint and add a skeletal mesh component. Assign the rifle as the mesh, then make the component a child of the character mesh. So pause here to set up your Marine's weapon, and then we'll take a look at how we can actually attach the weapon to the Marine's hands. Okay, so I've customized the material of this rifle that we're going to use for the Marine's weapon. I've gone for a white paint scheme. Back in my Marine blueprint, I've added a skeletal mesh component named rifle, and I've assigned the rifle as the mesh. This component is also a child of the character mesh. This is going to allow us to attach the weapon to the character's hands, so the character actually looks like it's holding it. Now to make this happen, we're going to attach the weapon to a socket. Sockets are like an attachment system in Unreal. They are used for attaching things to skeletal meshes. In games, we usually want to attach meshes to characters, like if it's a weapon in a player's hand, or holstered on the player's back, or even things like hats attached to a character's head. The way we do this in Unreal is by making use of sockets. So if we were to open up the skeleton of our Marine, we would see there is a bone called right weapon, but there's a socket added to this bone named weapon point. You can add sockets to any bone of a skeleton by right-clicking on the bone and hitting add socket, but we've already got one here, so we don't need to do that. We're going to attach our rifle weapon mesh to this weapon point socket on our character skeleton. So inside our Marine blueprint, with the weapon mesh selected, on the details panel we have this socket section. We can assign a parent socket for our weapon mesh by hitting this magnifying glass. Now I'm not sure why the selection goes all the way on the left, but in the selection here we can select different bones and sockets we can attach the rifle to. This is why we made the character mesh the parent for our rifle. If we didn't make the character mesh the parent, we wouldn't have any options here. So we can select the weapon point socket for our weapon. This makes the weapon attached to our character's hand, but it looks like it's disappeared. But it hasn't, it's just above the character because it's retaining its relative offset. To fix this, we could just reset the transforms back to 0 by hitting these yellow arrows. Okay, great. So now if we hit compile and save. And if we come back to our level and hit play, we can see that the character is now holding his rifle. But the next step for us now is to make it appear like the character is firing his weapon. And I've got a good challenge for you to get us started here. Create an action mapping named Fire Weapon, and bind the left mouse button and the right trigger of the gamepad to this, because this is what we're going to use for firing the weapon. Then inside your Marine blueprint, create two functions. The first named Start Firing Weapon, and the second named Stop Firing Weapon. Then inside your event graph, call the action event for Fire Weapon, and execute Start Firing Weapon when the action event is pressed, then execute Stop Firing Weapon when it's released. So pause the video here to attempt this challenge and then come back when you're ready. Okay, so I hope you had a go at the challenge. You should now have an action mapping named Fire Weapon that has the left mouse button bound to it and also the right trigger of the gamepad. Now inside your Marine blueprint, when we press the left mouse button or the right trigger of the gamepad, we should be calling a new function you should have created called Start Firing Weapon, and when we release, we should be calling Stop Firing Weapon. Now these functions aren't doing anything at the moment, but we are going to start adding some code to these. But what's actually going to happen when we fire the weapon? Well, we're going to spawn a particle system on the end of the weapon. We're going to spawn a muzzle flash. If we come back to the content browser, we can see we have this effects folder and we have some weapon effects here, and within the muzzle folder we have the assault rifle muzzle flash. If we drag it out, you might see that you have to compile some shaders, but when it's dragged out into the level you should see a looping particle effect like this. This is what we're going to attach onto the end of the weapon. We're going to attach it to a socket. So I'm just going to remove this from the level. I'm going to come back to my Marine blueprint. In fact, I'm going to make sure I have the muzzle flash selected in the content browser, because when I come back to my Marine blueprint and add a new component, we can see when we go to add a particle system, it automatically will assign our assault rifle muzzle flash here. Okay, so it's spawned into our character, but we want it on the end of our weapon. We're not going to just move it onto the end like this. What we're going to do is drag and drop it onto the rifle to make it a child of the rifle. And then with the muzzle flash selected, we can drop down the parent socket and we can assign it to a muzzle flash socket which is on the rifle. Now again, this is kind of moved away from the rifle, but we can just reset the transforms to set it back. Now this looks a bit silly at the moment because it's always playing. However, we can stop the particle from being active by scrolling down on the details panel. We scroll all the way down and we can find activation, and it's got auto activate checked. If we turn this off, we can see that the particle is now disabled. But for a final challenge for this lesson, I want you to activate the particle when we call Start Firing Weapon, and then deactivate the particle when we call Stop Firing Weapon. So pause here and have a little digging around in blueprints for the final challenge for this lesson. Okay, so if you did some exploring inside your Start Weapon Firing function, you should have a reference to your particle system component, so you can activate it by calling the activate function. Then you should be doing the same in your Stop Firing Weapon function, but you should be calling the deactivate function here. This means that if we come back to our level and hit play, when we hold down the left mouse button or the right trigger on the gamepad, our action event will execute the Start Firing Weapon function, which activates our particle. As soon as we release, we call the Stop Firing Weapon function, which deactivates our particle. So it kind of looks like we're firing the weapon now, but we could be reinforcing this with some audio. So in the next lesson, we're going to be setting up some weapon firing sounds. So once you're ready, I'll see you in the next lesson. Hey, and welcome back. So at the moment, our Marine is holding a rifle, and when we press the left mouse button or the right trigger of the gamepad, we play a muzzle flash particle effect on the end of the weapon. Now inside our Marine blueprint, we have our fire weapon action event that handles this. When we press the left mouse button or the right trigger, we execute our Start Firing Weapon function, or if we release, we execute the Stop Firing Weapon function. And these functions just basically activate or deactivate our muzzle flash particle. Now we're going to add some code to these functions to make the weapon feel more believable. We're going to be adding some audio. If we come back to the content browser, we can find the sounds folder, and there's quite a lot of audio that we can make use of in this project. We have a folder that contains the weapon sounds underneath the weapon assault rifle folder. We can come inside the stereo subfolder, and inside here we have a bunch of audio assets. You'll notice that there's two different types of icons. The first two we see here are sound cues. We'll be coming back to these shortly. And the rest of all of these assets are sound waves. These are basically just the raw audio files. And we can preview a sound wave by hovering over an asset and clicking the play button here. So we have some single shot sounds, but we also have some weapon looping sounds. Now we're going to play a weapon looping sound just like how we spawn a looping particle effect. We're going to play it as soon as we hold down the right trigger or press the left mouse button, then we're going to stop playing it when we release. But before we get to this, we're going to create our own sound cue. Sound cues are pretty much the audio equivalent of blueprints. They allow us to add a little bit of behavior to not just to one sound, but to multiple sounds at once. For example, a sound cue can combine and randomize multiple sounds, and we can even vary the pitch for each sound. There's lots of little nifty things we can do. Let's take a look at setting up a sound cue for our looping weapon fire sounds. Inside this folder, we're going to right click to create a new asset. We're going to come to sounds and then sound cue. Let's give this a name like rifle fire loop underscore cue. Let's double click on this to open it up. We can see we have an output. We don't have any sounds in here though. To get sounds inside our sound cue, we can just pull the tab off so we can see the content browser at the same time. And we can find our looping fire sounds. We can select one, then hold down left shift and then multi-select the different sounds, and we can click and drag them in. Now we can maximize the cue editor. Now with our sounds in here, we can plug one of them into the output, and that's how we basically connect a sound to the sound cue. As soon as we hit play, it's just going to play that sound. But what about multiple sounds? Well, let's break the link here. We can hold down left alt and left click, just like in blueprints. And with all of these sounds selected, we can right click and we can add some nodes here. If we come down, we can call the random node, and we can see that it automatically connects all three of these nodes to this random node. This means if we connect this to the output, anytime we press play, it's going to randomize which sound plays. But we can also drag out from the random output here, and we can call the modulator. Let's plug in the modulator to the output. You might not notice any difference here, but if you select the modulator, we can see that we can randomize the minimum pitch and the maximum pitch, and we can also randomize the volume. So if we set the pitch higher, it's going to sound like our weapon has a higher fire rate. So I'm going to set my minimum pitch and my maximum pitch to 1.2 to make it sound like the weapon has a higher fire rate. So how do we know if a sound is actually looping? Because you'll notice if we come and hit play at the moment, our weapon actually stops firing even though it says it's a loop. So to make it looping, we can select all of the sound waves and we can just simply check the looping checkbox. And now it will actually keep looping. Okay, so this is our cue now set up. Let's close it. And now we have our rifle fire loop cue. Now we want to call this or play it from our start firing weapon within our marine. So how do we go about that? Well, we're going to right click and we're going to spawn the sound. So if we type in spawn sound, there's different functions that we can call. We can spawn sounds attached to the weapon or at a location. So while these would be good, from a top-down perspective, we don't actually really need to do this. We can just spawn the sound 2D. This means that the sound isn't going to be spatialized in the world, but this is fine for our weapon firing sound. Let's hook this up to the start firing weapon. Let's choose our sound cue, which was rifle fire loop. And we have a return value for the sound. What we can do is store this as a variable. This can be our weapon fire sound. So as soon as we start firing our weapon, we spawn a sound, and this is actually a component. If we hover over the return value, we can see it's an audio component. We want to stop and destroy this audio component whenever we stop firing this weapon. So in stop firing weapon, we can grab the weapon fire sound that we just stored, and we can drag this out, and we can call stop. Now this is going to stop the audio components from playing, but usually we would have to destroy the components. But we don't actually have to destroy the components here, we can just call stop. We can hook it up to the execution pin, and let's come back to start firing weapon. we can see that if we expand the spawn sound 2D node, we can see we have this auto destroy checkbox. And it tells us that if this is checked, the sound will automatically be cleaned up. Basically, it will destroy the component whenever the sound stops playing. This is why we don't have to call destroy components, because whenever we call stop, the component will automatically be destroyed from the world. So we don't actually need to call destroy component. It's fine just to call stop. Now let's come back to our level and hit play. So when we start firing, we play the weapon fire sound, and when we stop firing, it stops playing the sound, but it sounds a bit weird when we stop firing. Inside this folder, we have these shot end sounds, which sound pretty good whenever we stop firing the weapon. So we're going to spawn these whenever we call our stop firing weapon function, but I'm going to challenge you to set this up. Create a new sound cue called Rifle Fire End Cue. Make use of the rifle end shot sound waves. You might want to make sure that you match the pitch of your looping fire sound, but you won't need to loop these end shots. And the big step to this is to make sure that you spawn this new sound cue whenever you stop firing. So pause here to set this up, and then we can wrap up this lesson. Okay, so I've created a new sound cue that makes use of these end shot fire sounds. So we're going to spawn this rifle fire end whenever we stop firing our weapon. So inside the stop firing weapon function within the Marine blueprint, we are going to right click and call spawn sound. We're going to spawn the sound in 2D space. Let's hook this up to the execution pin here, and let's just call our new fire end sound cue. And remember, we don't need to destroy it or anything because it auto destroys automatically. Awesome, so we can hit compile and save. Let's just come back to the event graph to double check everything. So whenever fire weapon is pressed, we execute our start firing weapon function, which spawns our muzzle flash particle effect, and then we spawn the looping weapon sound. And we store this as a variable, which helps us when we stop firing the weapon. Now let's come to the stop firing weapon function. This executes when we release the left mouse button or the right trigger of the gamepad. We simply stop the muzzle flash from spawning, and we stop our looping rifle weapon sound, and then we spawn the end shot sound. Now let's come back to our level and hit play to hear what this sounds like. So it's much more convincing that we're firing a weapon now. You now know how to create sound cues and spawn non-spatialized audio, and we'll be taking a look at spawning spatialized audio later on, but for now our weapon is pretty much there. We can't really do too much more until we have our aliens running around after us trying to attack us. Before we get to them, we're going to create the player's HUD. So once you're ready, I'll see you in the next lesson, where we're going to take our first look at Unreal Motion Graphics. Hey, and welcome to this lesson where we're going to start designing a HUD for our player character, so we can see things like how much health he has and how many aliens he's killed. So to create our HUD, we're going to be using Unreal Motion Graphics. Unreal Motion Graphics is Unreal's user interface designer. It allows us to create things called widgets that can be used to lay out visual assets on a canvas. So we're going to be using this to create our own player HUD widget. To get started, we're going to look in our content browser to where we have the UI folder. Inside the UI folder, we're going to right click in here and then come to user interface, and we're going to create a new widget blueprint. We're going to name this W for widget underscore player HUD. And let's double click on this to take our first look at creating a widget. So the first thing I want to point out is this hierarchy panel. This shows us all the different elements that make up our widget. And we can see that it only has one element in here, which is a canvas, and that's what we see here in the center window. This is our canvas. This is what we place assets into, and this is where we're going to arrange our player HUD. We can add assets to our canvas from the palette panel. There's many different elements we can use, but to start with, let's just drag in some simple text. So this is just some basic text, and you can see on the details panel that you'll find lots of different settings for customizing it, including the font size and the color. But the main thing to understand here is that you can customize the text that is displayed by editing the text content. After you've edited the text, once you hit enter, the text will be updated on the canvas. We'll begin to see how we can make our text more dynamic in the upcoming lessons by updating what is displayed from blueprints. So that's the text, but what else do we have on the palette that will come in handy? Well, we can drag out an image. An image is an asset that we can use to assign images and textures. If we come back to our content browser under the UI folder, you'll notice that we have a textures folder here. Inside this folder, we'll find some textures that we can use for our images. For example, we have this marine portrait. To use this as an image in our widget, we can first select the image in the content browser, then inside the widget, we can look towards the appearance section. We can expand brush, and this is where we can assign images or textures. And because we have the marine portrait selected in the content browser, we can hit this little arrow here to assign it. Now we can click and drag and resize our images, but you might find that they end up stretching a little. But if we look back towards where we assigned our image, we can see the actual size of the image in pixels. So it has a uniform size of 200 by 200 pixels. This means that as long as we resize the X and Y to the same values, it won't stretch. And we can adjust the X and Y size values just above where we assigned our image. So for example, we can make our image smaller and not stretch by just setting it to 75 by 75. And we're free to move and place the image anywhere on the canvas. Okay, so that's how we can assign images. What else can we do that's relevant? Well, if we want to display a character's health bar, we can use a progress bar from the palette. We can see how a progress bar would work by adjusting the percent from the progress section when we have it selected. We'll eventually make some blueprint code that will read our player health and set this dynamically. Okay, so I think text blocks, images, and progress bars are really all we need right now, but there's one final thing I want to point out. When you have an asset selected, you will notice this kind of flower-like icon. This is an anchor point. Anchor points are used to make sure that the widget maintains its position across different screen sizes. I'm attaching a link to Unreal's documentation that goes into a lot of detail, so make sure to check out the resources in your own time. But just as a quick rundown, the best advice I can give is just to set the anchor point to the closest corner that is near your asset. You can do this by dropping down the anchor drop down in the details panel. But if your asset's closer to the center, then just set the anchor point to the center. This should give you the best results. Now I want you to pause here and take some time to lay out your own HUD for the player. Make use of the text, images and progress bars from the palette to lay out your player HUD. We're going to want to display a health bar for the character, but we also want to display a counter for how many aliens the player has killed. Now you don't have to lay it out exactly how you see here, add your own touch to it. Feel free to move assets around and use different colours or text. So pause here to set up your player widget, and then we'll take a look at how we can display it when we play the game. Okay, so this is how I'm going to lay out my HUD. I've got my marine portrait here in the top left, and I have a title for some text saying marine health, and I have the progress bar here. It's all coloured green to represent health, and in the top right, I'm going to show the kills that the player has, with a separate text block for the kill counter, and just a title of kills underneath the image here. Okay, so this is all I'm going to do for now inside this widget. I'm going to hit compile and save, and let's see how we can actually make this widget appear in the game. First, we're going to come to our character blueprint, and on begin play, we're going to drag out from begin play. We're going to type in create widget. We're going to create our player HUD widget. This will construct the widget, but it's not going to show us what the widget does until we drag out from the return value to make the widget appear by calling add to viewport. So that will add it to the player's viewport. And now if we hit compile and save, we can come back to our level and hit play, and we see that the HUD spawns whenever we play the game now. We can also press F11 to go into full screen mode, so we can see more of the HUD here. Hello and welcome to this lesson where we're going to update elements of our player HUD. We're going to want our progress bar to read the player health, so it updates and acts as a health bar. And we're also going to want to update our alien kill counter. Now of course we don't have any code or properties inside our marine blueprints yet that handles damaging the player or storing their kills. We'll get to this shortly, but first let's focus on our widget. We've been working in the designer so far. However, in this lesson, we're going to switch over to this graph view. So while we can design widgets, widgets are also blueprints, so we can add code to them to drive their behavior. We're going to create a variable that is going to hold a reference to our marine blueprint. Let's hit new variable, let's call it marine, and let's change the variable type to our BP marine. So we're going to type in BP marine, we're going to get the BP marine here, and we're going to select object reference. Now let's hit compile. This reference isn't going to be set to the player's marine by default. We have to manually set this. We want to make it so when we create our widget, we set the value of this reference to be the player's marine. We create the widget inside the marine blueprint. In order to set the marine reference within our widget, we want to make it appear on this node as a pin. And this is going to be really easy to do. We can just select the variable and we can expose it. We can hit instance editable. We need this checked in order for us to hit expose on spawn. And it tells us when we hover over this, should this variable be exposed as a pin when spawning this blueprint. So if we check this and hit compile and come back to our marine blueprint, it doesn't look like anything's happened here, but if we right click on this node and we can hit refresh node, it now updates with a pin so we can set our marine reference. We can simply drag this out and we can type and search for self. So now when the game starts, we create our HUD widget and we set the marine reference to be the player's marine. And by having this reference to the marine blueprint in our widget is going to be able to read properties such as the player's health and how many kills they have. But we don't have these properties yet inside our marine blueprint, so I want you to go ahead and set these up. Inside the blueprints for your marine, create a float variable that we can use for the player's health. Then create an integer for storing the player's kills. So pause here quickly to set these up, and then once you've done this, come back and resume the lesson. Okay, so inside the marine blueprint, we should now have a float variable named health and an integer named kills. I've set the default value for the health to be 100 and the kills is set to 0. I've also put both of these inside a category named player properties. Now, how do we update our kill counter and our progress bar to read these values? Well, we're going to create a property binding. A property binding basically allows us to take things like our progress bar or our text and bind them to read the return value of a function or to read a value of a variable. If we select our progress bar, we can see just next to percent we have bind. We can drop this down and create a binding. So what does this do? Well, this creates a new function with a return value. Before we do anything, let's rename this function to getHealth. Let's make sure that we hit compile so we apply the name, and let's come back to the designer. We can see now that our progress bar is bound to a function named getHealth. So the progress bar is always going to update itself to match the return value of the getHealth function. And we can make this function return the player's health. We can get our marine, and we can get the health. And we can plug this straight in to the return value. So how do we know if this works? Well, if we come back to our marine blueprint, we can change the health to be 50. So the health bar should be half full. And we can see that it's still full. So why is this happening? Well, this is because of the value range of our progress bar. We can see that it only goes between 0 and 1. It doesn't go between 0 and 100. So we need to take the health from the marine here and divide it by a float. We can divide it by 100 to make it go between 0 and 1 instead of 0 and 100. So now if we come back to the level and hit play, we can see that the health bar is now half full. And just to confirm that this works, you can change the default value of the marine health and then play again to see that the progress bar is correctly matching the health variable. Awesome, so we've now bound the progress bar to read the player's health. Now I want you to pause here and have a go at creating a binding for the kill counter so that it reads the amount of kills from the marine blueprint. Okay, so to create a binding for the text counter, we're going to select the text that we want to bind the kills to. We're going to drop down bind next to where we set the text, and we're going to create a new binding. So this creates a new function that returns some text. And the text on the canvas is going to be bound to the return value of this function. So what we're going to do is make this function return the amount of kills of the Marine. So with the Marine, we're going to drag it out and type in get kills. And with the kills, we can simply drag and plug it straight into the return value, and it will convert the integer to a text value. And we can give this function a better name than what Unreal's given us. We can rename this to get kills as text. And now we can hit compile, and we can come back to the designer. Our text is bound to the return value of our function named getKills as text. And now we can come to our Marine, and we can change the default value of kills to something random just to make sure it works. We can put 408 as an example. So if I hit play now, my HUD should show that I have 408 kills, and it does. So this text is definitely reading our kills variable from our Marine blueprints. Let's just set this back to 0 because we don't want to start with 408 kills. Now I'm going to leave you with this final task of renaming the assets that we have in our player HUD. We can see that if we select any of them, Unreal has given them quite an ugly name. It says text block 105. So we can simply rename this to something like text block kill counter. So before moving on to the next lesson, I just want you to take some time to rename the elements of your player HUD. And that's the end of this lesson. In the next lesson, we're going to start setting up the aliens that are going to spawn and attack the player. So once you're ready, I'll see you in the next lesson. Hello and welcome to this lesson where we're going to start working on some AI that's going to chase down the player. Inside the characters folder in the content browser, we have this spider that we're going to make use of for our Martian aliens. So to get started, we're going to create a new character blueprint and assign this spider as the mesh. Inside our blueprints folder, we can create a new folder called AI. And within this AI folder, we're going to create a new blueprint class, and it's going to be a character. We're going to name it BP_alien. And we can double click on this to open it. And let's start by assigning the spider mesh to the mesh component. So we're going to drop down the skeletal mesh here and choose the spider. Now it may take a second for it to load for you, and you may have to compile shaders, but once it's done, you'll have this giant spider in your blueprints. Probably too big for us right now, so let's make it half the size. We can reduce it to 0.5 for the scale. And we can rotate it so it faces the forward-facing direction, the same as this arrow component here, and we can bring it down so its feet kind of are level with the bottom of the capsule. Okay, now you'll notice that the spider comes with its own animation set that you can find in the content browser. Now, I'm going to challenge you to set up an animation blueprint by yourself. Create an animation blueprint for your alien. In the anim graph, create a state machine that contains two states. The idle state, which will play the idle animation, and the walk state that will play the walk forward animation. Then in the event graph, calculate the AI's movement speed and store it as a variable, so that you can then set up the transition rules for your state machine by making use of the AI's movement speed. So pause here and take your time with this. Remember, you can always refer back to your Marine's animation blueprint to help you guide you through this if you get stuck. And then once you're ready, come back to the lesson and we can carry on. Okay, so I've created an animation blueprint for my alien, and I hope you have too. I'll just take you through my setup, but it's basically the exact same as what we did with our Marine's animation blueprint. In the events graph, on begin play, we store a reference to the alien. Then every frame, if the alien is valid, we calculate the movement speed and store it as a variable so we can access it inside the anim graph. And to calculate the movement speed of the alien, we get its velocity and call the vector length function, which will return its speed. Now inside the anim graph, we just have a state machine that contains the idle state that plays the idle animation and a walking state that just plays the walk forward animation. We enter the walking state from idle if the movement speed is above 0, and we enter the idle state from walking if the movement speed is equal to 0. So if we come back to our AI blueprint for the alien, we can come to the viewport, and we can select the mesh component, we can drop down the anim class, and assign our new animation blueprint to it. And we can see that it starts animating straight away. Awesome, so we're now ready to switch over to the event graph so we can start adding some blueprint code to make this alien chase the player. Take note that if you have a pawn that isn't possessed by a player when the game starts or when the pawn spawns, an AI controller will automatically be created and assigned to the pawn. This is why if we call any AI functions, the class will respond and navigate around the world. And this is what we're going to do right now. We're going to start setting up some AI for our alien. Inside the blueprints for our alien, we're going to right click and we're going to come to the AI category. Inside here, we can call the AI Move To node. And it says here, it's a simple order for pawns with AI controllers to move to a specific location. So we're going to use this node. We provide the pawn that's going to move, which is just going to be self. It's going to be this alien. And we can either provide a destination or a target actor that it moves to. We don't have to provide both. We can ignore destination if we have an actor that we want it to move to. We want it to move to our player character. So we can right click and just call get player character, and we can plug that straight in to the target actor. On begin play, we can simply get the AI to move to the player. Now we can hit compile and save. We can close the blueprint, and let's drag an alien into the level. You'll notice that if you hit play, the AI doesn't move at all. This is because we need to provide a navigation mesh in our level. Navigation meshes are simply used to tell the AI where they can or cannot navigate in our levels. We're going to add a navigation mesh to our level now. To add a nav mesh to our level, we can look towards the modes panel. We have the volume section. If we scroll down on the volume section, we can find the nav mesh bounds volume. We can drag this out into our level and we can scale it up just like any other volume. We can press P to visualize how the nav mesh is perceiving our level. We can see that it's detecting our rocks, it's telling us that the AI can't walk there, and it's saying that the AI can walk around the rest of the level on the ground. And this is why the AI didn't work a moment ago. When we tried playing, we didn't have a nav mesh, so the AI didn't know where it could or couldn't walk. But now if we play the game, we can see that the AI is running directly towards us, but it's moving pretty quickly, and you'll notice that once the player exits the nav mesh volume, it will stop moving, and even if the player returns into the nav mesh, the AI is stuck again. And if we play again, and you'll notice that if the AI reaches the player, and if the player moves away, the AI will stop following them. So let's fix the AI speed and these issues we have here so the AI can continuously chase the player. Inside our alien blueprint, let's start with the movement speed. We can select our character movement component and we can change the max walk speed. I'm going to use a speed of around 375. Now the reason the AI stops moving if it reaches the player or if the player exits the nav mesh is because we only call the AI move to node once on begin play. Once the AI reaches the player, the on success output pin will execute, but it's not hooked up to anything, so the AI will stop. And the same goes for on fail, which will execute when the player exits the nav mesh. To make the AI continuously chase the player, we're going to drag out from the on success pin, and we're going to call a delay. We're also going to hook up the on fail output to the delay as well. So if the AI succeeds or fails to reach the player, we delay by 0.2 seconds, and then we can drag out from the completed output and call the move to again. So we just continuously execute our AI move to node. We can double click on the execution wire to add some reroute nodes as well, just to make this a bit more tidy. So on begin play, the AI moves to the player, and if they succeed or fail to reach the player, they will delay by 0.2 seconds and then try again. So now if we compile and save for the final time for this lesson and close this blueprint and hit play, we can see that the AI is moving slower and they're chasing the player. If the player moves out of the nav mesh now, we should see that the AI will stop at some point. There they go, so they're stopping because they can't reach the player, but as soon as the player re-enters the nav mesh, the AI will chase them again. And if the AI reaches the player again, and if the player moves away, we can see that the AI will still chase the player. So let's wrap up this lesson with a summary of the goals for our AI. We want the AI to chase the player, and they're already doing that, but also we want to make sure that the AI attacks the player when in range. The AI must cause damage to the player and eventually kill them, but the AI needs to receive damage as well when the player shoots them. The player should be able to damage them and eventually kill them. And the final step is to make our AI spawn in waves. So you now know how to add nav meshes to your level and how to get AI moving by calling the AI Move To node, which allows us to start tackling the rest of these goals over the next few lessons. So we have our alien chasing the player, but once they reach the player, nothing happens. So in this lesson, we're going to make it so when the AI is within range of the player, they will stop moving and start playing an attacking animation. So to start setting this up, we're going to head into our alien AI blueprint. We're going to create a new function, and this function is going to calculate if the alien is within an attack range of the player. So let's name this function is within attack range. We're going to make this function a pure const function. And to calculate if the alien is within an attack range, we're going to call an Unreal function named getDistance2. And this function simply returns the distance between two actors in Unreal units. Now remember, one Unreal unit is equal to 1 centimeter. So if this returns 100, this means that the distance is 1 meter. And we have two inputs on this function. The first target input is self, which means this blueprint. So we can compare the distance of this alien to another actor. Now I could go on and show you how to set up the rest of this function, but I want you to apply your knowledge and finish off setting the rest of this up. This function should return if the alien is within an attack range to the player. So get the distance of the alien to the player character, then check to see if the distance is less than an attack range. Now you won't have an attack range, but you can create one. Then return the result as a return value on the function. So pause here to set up this is within attack range function, and don't worry if you get stuck, we'll go through this once you come back and resume the lesson. Okay, so here's my is within attack range function. I've also created a float variable to use as the attack range. We get the distance of the alien to the player character. Then we compare the distance to see if it's less than the attack range by using our variable. Then we return the result of this comparison as a return value on this function. So I've set the default value of my attack range to be 150 units. So this is basically 1.5 meters. And it's important to note that when we get the distance of the alien to the player character, it chooses the alien's actor location, which is going to be the location of the root component. It's going to be right in the center of the capsule, basically where the arrow component appears from. So just keep this in mind when you choose your attack range. So let's come back to our event graph. We're going to call this function onTick. We're going to use a branch, connect this up to the tick, and we're going to use the function as the condition for the branch. So every frame we're going to check to see if the alien is close enough to attack the player. Now what happens if the alien is close enough? What are we going to do? Well, we're going to play an animation montage. Animation montages are an animation asset that we can create through the content browser. There's many different things we can do with them. They allow us to combine multiple animations together, they can loop sections of animations, they can trigger events at particular points in the animation, and more. But we're going to use animation montages at a very simple level. Animation montages are quite handy for us to use because they will allow us to trigger animations through Blueprint's code. Once we trigger an animation montage, it will play, but once it finishes, the character will automatically return back to playing the animations inside their animation blueprint. So we don't have to worry about setting up some code to play an animation and then adding some more code for once it finishes to go back to playing the animation blueprint again. The anim montage is going to handle all of this for us. So let's take a look at creating and setting up an animation montage. Let's come to the folder where we have all the animations for the spider that we're using for our alien. We actually already have an animation montage in our project set up. It's with the blue little thumbnail here, but let's ignore this for now. We have a few attack animations that we can use. We're going to take one of these attack animations and then create an animation montage from it. To do this, we can come back to the content browser, we can find the animation that we want to use, and we can right click on it and come up to create, and we can create an anim montage here. We can just name this Alien Attack 1. Now let's double click and open up the montage to take a look at it. Now there's not too much we need to worry about, it just looks like a regular animation, but there's a few things I want to point out. The montage shows us which animation is playing, and we can drag and drop animations here to make the montage play multiple animations at once, but we're going to just use a single animation for our montage. We can adjust the speed of the animation montage by changing the rate scale. The animation looks okay now, but we're going to want it a lot more faster paced. We want to make this a really quick swipe at the player, so we're going to increase this to 2.5. So it's a lot quicker now. And the final thing to take a look at is this little drop down here. Montages are assigned what's known as a slot. We can come up to Window and then open up the Anim Slot Manager. We only have one slot that's in a group that Unreal creates by default. And this is fine, we don't need to add any more slots or groups, but slots are used to organize our montages. And I just wanted to show you how to find the slot manager and how to create new slots and groups. But I haven't really explained what a slot is. A slot is something we can add into the anim graph of the animation blueprint to say where we want the montage to trigger. Let's come over to the animation blueprint. So by default, if we were to tell our alien AI to play a montage, nothing will actually happen because our animation blueprint isn't set up to play montages. This is where the slots come in. Our montage is assigned to a slot called default slot. We can right click and we can type in montage slot, and this shows us all of the slots that we can use, and we only have one here, so we can select the default slot. We can hook up the state machine into the slot, and then the slot will connect back to the final animation pose result. We can hit compile to get rid of the note. So by adding the slot to our anim graph, our animation blueprint will now listen out for and play any animation montages when requested. And this is all we need to do here. We can hit compile and save, then we can close the animation blueprint to come back to our alien AI blueprint. So how do we play an animation montage from blueprints? Well, it's quite simple. We can just right click and we can type in play montage, and we're going to get the one that's highlighted in green here, this play montage node. We can see it has many different output pins and input pins on this node. Now there's something we need to be aware of. We need to be aware of the way that we're setting up our code at the moment. We're calling our code on tick. So we can't just continuously execute this play montage on tick, because every frame the montage will just restart. So before we make our alien play the attack montage when they're in range, we first need to make sure that the alien is not already playing the attack montage. So it will only play the attack montage if it's not already playing. Okay, so to do this, we're going to create a new function. We're going to call this is attacking, and we're going to make it pure and const. This function is simply going to return if the alien is attacking or not. We need to start by asking if the animation blueprint is playing a montage. But how do we gain access to the animation blueprint? Well, first we need to grab the mesh component, because the animation blueprint is going to be associated with the mesh component. We can drag this out and reference the animation blueprint by calling the getAnimInstance function. We can think of this as getting the animation blueprint. Now with this, we can drag out the return value, and we can come to the montage category, and there's many functions here for dealing with montages. Now remember that the green F is for pure functions and the blue F is for impure functions. Now I want you to pause here and see if you can find a function that checks if a montage is playing. You want to check if the alien attack montage is playing, and we want our isAttacking function to output the result as a return value. So pause here to see if you can find the correct function to use and to finish setting up the rest of this function, and then we'll be ready to make the alien play the montage. Okay, so here is my isAttacking function. We get the mesh, we get the animation blueprint, and then we check to see if a montage is playing, and we can choose the montage here on the drop down. So we choose the alien attack 1, and then we take the result and make it a return value on our function. So this function now tells us if the alien is attacking or not. So now we can come back to our event graph, and we can call our isAttacking function. We can move the montage just further along here, and we can use a branch again. So we can say every frame, is the alien within the attack range to the player? If they are, then we can execute this branch with the condition of if the alien is attacking. Now, if the alien isn't attacking, we can then go ahead and then play the montage. And there's one thing I forgot here. We need to provide the skeletal mesh component for the montage. So we're just going to plug in our mesh component straight into this. And we also need to make sure that the montage that we play is our alien attack. Okay, we can still clean this up, but let's just test it out for now. We can hit compile and save and come back to our level to test it out. So we can see that the alien moves towards us, and when it gets close, it starts playing the attack montage. And when the player moves away, it stops attacking and starts chasing the player. Now we'll add some code to stop the AI from moving when they attack, but first, let's come back to our blueprint to clean up our code. We say that if the alien is within the attack range, and if it's not attacking, we then play our animation montage. So it looks like we need both of these branches here, but actually we only need one. We can remove this second branch, we can bring the is attacking function back underneath this is within attack range function, and we can break the condition on the branch, we can drag out from the condition and type and. So we can say that if the alien is within the attack range, and if the alien is not attacking, how do we say not? Well, we can drag out from the return value, and we can just simply type in not and get the not boolean. And we can plug this straight into the second input on the and. So if the alien is within the attack range and if it's not attacking, then go ahead and then play our animation montage. So that cleans up our code, so we only have one branch, but what about deactivating the alien's movement when it goes to attack the player? Well, we can grab the character movement component and we can simply deactivate it when we go to attack the player. And then we can play the montage. But then once the montage has completed with this onComplete output pin, we can then get the character movement component again and then activate the movement. And if we want to, we can collapse these down into functions called deactivate AI movement and then also activate AI movement. Okay, so we deactivate and activate the AI movement when the alien attacks the player. So let's compile and save for the final time for this lesson, and let's come back and hit play. So the alien runs up to the player and it attacks, and if we move away, we can see that he's no longer sliding and running after us while he's attacking. Now he looks like he's attacking us, but he's not causing any damage to the player. So in the next lesson, we're going to set it up so the alien can actually damage the player. Okay, so we want our alien AI to damage the player whenever the alien attacks. When the player gets damaged, we want the player's health to decrease, and once the health hits 0, the player should die. So to get started with this, let's enter the alien blueprint to create a new function called damage player. To cause damage to the player, we're going to make use of Unreal's damage system. We can bring up the action menu and we can call the apply damage function. We can provide the actor that we want to damage. We want to damage the player character, so we're going to call get player character to use for the damaged actor. And we can provide the damage that we want to apply. We're going to right click on this pin to promote it to a variable called damage per hit. And we can hit compile to assign a default value. So every hit my alien does, I'm going to apply 15 damage, and we're promoting it to a variable so we can easily tune how much damage the alien does. So this is our function complete. It's very simple. We just call apply damage on the player character. But we want to call this function in the middle of our alien attack montage. To do this, we're going to make use of anim notifies. Anim notifies are short for animation notifications. We can use anim notifies in both animations and animation montages. They allow us to execute events at particular points during an animation. So this can be used for things like footsteps. We can spawn sound effects or particle effects when a character's foot hits the ground, but they can also be used to execute our own code. We're going to create an anim notify inside our alien attack montage so we can execute the damage player function from our alien AI blueprint. So let's open up the alien attack montage. We want an event to execute whenever the alien is just at his full swipe. So we can pause the animation and we can scrub along on the animation timeline to where we want the attack to happen. We want it just to happen right around here. Now if we scroll down, we can find the anim notify section. To create a new anim notify, we can right click in the notify section where we want to create a notify, and then we can come to add notify, then we can select new notify to create a new one. Now we can name this, let's just name this attack, and this is all we need to do here. We have the anim notify in our montage, and because we created the anim notify, we can now implement the event for it inside our animation blueprint. So let's come back to our animation blueprint, and let's switch over to the event graph. Now in an empty space, we can bring up the action menu to search for the notify, which we called attack. So whenever the alien attack montage plays and hits our attack notify, this event will execute. Now this means that we can get our alien reference, and then we can call the damage player function we created inside the alien blueprint. So whenever the notify executes, we damage the player. And this is all we need to do here, so we can compile and save the animation blueprint and then close it. So the alien can damage the player, but this doesn't mean much yet because we haven't implemented the any damage event inside our marine blueprint. Whenever the marine receives damage, we need to subtract the marine's health by the amount of damage being applied. So let's come back to the content browser and let's open up the blueprints for the marine. Inside the events graph, let's come to an empty space, and we can implement the any damage event by right clicking and typing and searching for event any damage. Now remember, our marine already has a variable for his health. It's under the player properties category. We can get the health, and then we can subtract it by the amount of damage being applied by calling the float subtract float node, and we can hook up the damage from the event into the input for this. So now whenever the marine gets damaged, we get his health and then subtract it by the amount of damage being applied. But we need to drag out the health again and select set this time, so we can set the health whenever the player receives damage with this new value. Now we probably want to clamp the player's health to a range, so the player's health can never go below 0. To do this, we can select the health variable, and then on the details panel, we can change the value range, so it goes between 0 and whatever we want the maximum health of the player to be. I'm just going to use 100. And I'm also going to set the default value for the health to be 100 as well. And we can hit compile. Awesome, so whenever the player receives damage now, we actually decrease the health and it will never go below 0. We can select all of this code here and we can collapse it down into a function called decrease health. And we can change the name of the input pin to damage amount. And let's enter this function and make the function also return the player's health. We can just move these nodes down, and then we can right click and add a return node. And we can use the output pin of the set health so we can return the health. And we can also rename this output pin to just simply health. So now if we hit compile and come back to the event graph, we can see that anytime we damage the player, we decrease the player's health, but we also get the new health on the end of this decrease health function. This is going to help us check if the player is dead. So to do this, we're going to create a new variable called dead, and this is going to store if the player is dead. We want to make sure that this is a boolean, and we can hit compile and make sure that the default value is definitely set to false. So whenever we start the game, the player is not dead. But we want to set this variable to true whenever the player's health is equal to 0. So we're going to drag out the health return value on our decrease health function. We're going to check to see if it's equal to 0. We can hold down B and left click to add a branch, and we can use our equal comparison here as the condition for the branch. Now we can grab our dead variable and set the player as dead from the true output of the branch. So whenever the player receives any damage, we decrease the player's health, we check to see if it's equal to 0, and if it is, we set that the player is dead. So this is good progress. You'll notice that the player's health bar will now decrease when the player is damaged, but once the player loses all of his health, nothing actually happens and we can still run around as usual. So we really need to make it more believable that the player has died. When the player is killed, we want to disable the player's movement. We want to disable the aiming and also disable the ability to fire the player's weapon. If the player dies while firing the weapon, we need to make sure that we stop the weapon from firing. And the final step to really make the player's death convincing is to make the Marine play a death animation. Now, in order to disable a lot of the player functions, we first want to check if the player is alive before we execute them. So if the player isn't alive, the functions won't execute. Now let's create a very simple function that returns if the player is alive. Let's create a new function inside our Marine blueprint called isAlive. We're going to make it pure and const. Now this function is going to be really simple. We're going to make this function simply return if the player is not dead. We're going to grab our dead variable. We're going to drag it out and just type in not, and we're going to grab the not boolean function. Now we're going to add a return node and simply return if the player is not dead. And we can just make sure to hook up the execution pin here. So how does this help us? Well, if we come back to the event graph, we only want the player to be able to fire the weapon if the Marine is alive. So let's enter this start firing weapon function. Let's move these nodes along inside the function. Now we can grab the function we just created that returns if the player is alive. We can use this with a branch, and we can execute the code that fires the weapon only if the player is alive. Now we don't need to do the same thing inside the stop firing weapon function, because if we did do the check and the player dies, then we wouldn't be able to stop the weapon from firing, it would be stuck firing. So we're actually going to call our stop firing weapon function when we know that the player has died. So we can just grab stop firing weapon and drag it out onto the graph and hook it up to the execution flow when the player dies. So now when the player runs out of health, we set them as dead and we stop firing their weapon. So this means that we've completed 2 of our objectives for making the player death appear more believable. Now I want you to disable the player movement and the aiming if the player is killed. So pause here and set up your code so you only allow your player to move and to aim if they are alive. Then once you've done this, come back and resume the lesson, then we'll take a look at setting up the death animation. Okay, so you should be checking now if the player is alive before we add any movement input. And where we go to update the player aim, we can enter this function, and we can simply check if the player is alive before we update the player aiming. Now let's come back to our level to test this out. The alien walks up to us, it decreases our health, and as soon as it hits 0, we shouldn't be able to move or aim. But as we can see, we can still aim and we can still move around, so something isn't working. So how can we debug this? Well, we know that the health is definitely decreasing because we see it decreasing on the health bar. So it's something to do after we decrease the health. Let's toggle a breakpoint where we set the player as dead. So this means if we come back to our level and hit play, Unreal should kick us out into the blueprint as soon as the player gets set as dead. And as we can see, this isn't happening, so it's actually before we set the player as dead. I think I know what it is. I think it's the health. If we drag this out and type toString, we can convert the float to a string, and then we can drag this out and call printString, so we can print the value of our health. This can be ugly for now, we'll remove it afterwards. We can come back to our level and hit play. I think the health isn't being clamped, so it keeps going down, and as soon as it hits 0, yep, it keeps going below 0. So the value range isn't actually working on our health variable. But this is okay, we can just manually clamp the health ourselves inside the decrease health function. Before we set the health and after we subtract it, we can just drag out from the subtraction node here and type in clamp and get the clamp float function. So we can clamp it between 0 and the maximum health of the player, which is going to be 100 for me. And we can hook this up into the set health node. So if we come back to the event graph, let's just make sure we've removed our breakpoint, which we have. So let's come back to the level and hit play now. So the alien comes towards us, reduces our health. As soon as it hits 0, we can no longer move or play. But as we can hear, we have this horrible rifle end sound spawning. So let's take a look at fixing this issue as well. This is happening because of our stop firing weapon function. We call this spawn sound 2D node to spawn the rifle end cue. But every time the alien attacks the player when the player is dead, we also call stop firing weapon. So this is why we keep hearing this sound. In order to fix this, we only want to call this spawn sound 2D node inside the stop firing weapon function whenever the player is alive. So we can use our function with a branch here again and just make sure that we execute this if the player is alive. And we still definitely want to call stop firing weapon whenever the player dies because we don't want the weapon to get stuck firing. So let's just try this again. So the alien comes towards the player, damages them, and then once the player's health reaches 0, the player can no longer move, aim, or fire, and we don't hear any of those annoying audio issues. Awesome, so the only thing missing now is the death animation, and I want you to try setting this up as the final challenge for this lesson. The Marine comes with his own death animation in the project, so inside your Marine animation blueprint, set up a state inside the state machine that plays the death animation. Then only enter this death state if the player is no longer alive. So you'll have to make use of the anim graph and the events graph to fully achieve this in your animation blueprint. But pause here and give this final challenge a go, and then we can wrap up this lesson. Okay, so well done if you got this working. Inside the animation blueprint for the Marine, within the events graph, we can grab our Marine reference, and we can either call our isAlive function or the dead variable that we have inside our Marine class. I'm going to call the variable. We can store this as a variable inside the animation blueprint so we can access it in the anim graph. Now once we store the variable, we can hook up the execution pin, then we can hit compile and then head into the state machine. And we can add one new state called def. Now we can enter the def state and we can play the def animation. And to enter the def states from the movement's blend space, we just need to set up this transition rule, which is going to be quite simple. We can just provide our dead variable here. So if the player is dead, then we can enter the def state. But if your variable returns if the player is alive, then this is fine too, but you would just have to make use of the not boolean function on this. So if the player is not alive, then you can enter the def state. But there's one final trick we're going to do with this. Inside the def state, we're going to select the animation, and we're going to make sure that it doesn't loop. We're going to turn off the loop animation checkbox here on the details panel. So this means if we come back to our level and hit play, the alien's going to damage us and eventually kill us, and the player goes into his death animation and it doesn't loop. So he just stays there dead. We can no longer move around, fire our weapon, or aim. Okay, great, so we've now completed all of these tasks to handle the player's death, and we've also crushed a couple of bugs as we set all of this up. So that wraps up this lesson. In the next lesson, we're going to do the opposite and make it so the player can cause damage and kill the aliens with their weapon. Hello and welcome to this lesson where we're going to set up some blueprint code so that the player can damage and kill the aliens in our project. To do this, we're going to perform a trace. Now you may have heard of the term raycasting. This is the same thing as a trace in Unreal. A trace is going to allow us to retrieve information from the world by drawing a line or a shape between two locations and checking if anything is colliding between these locations. So to perform a trace, we have to provide a start location and an end location. Now there's different shapes we can use for tracing, but we're going to perform a line trace. Our start location for our trace is going to be from the barrel of the player's weapon. Then for the end location, we're going to calculate a location that's way out ahead in front of the player's weapon. Now when we perform the line trace using these locations, the trace will collide with any actor that blocks its path. And all of the information about what the trace hits is contained within the hit result that gets returned on the line trace function. We can query the hit result to find out things like what actor was hit and the world location of the hit. Now the function we're going to use in Blueprints is called line trace by channel. This is what we're going to use instead of spawning projectiles for the weapon. We're going to cause damage to any actor that the trace hits. So let's take a look at setting this up. I'm going to start by removing the alien in the level so he doesn't come up and try to kill us while we're testing and setting up the weapon code. Now let's head into our marine blueprint. We're going to create a new function named weapon trace, and this is going to be an impure function. We're going to call this function in the event graph whenever we fire the weapon. Let's drag it out and call it after we execute start firing weapon. But take note that by executing it here, this means that it's not going to behave like an automatic weapon. As soon as we press the left mouse button, it's just going to fire a single shot. But this is okay for now. We can work with this while we set this up, and then we'll take a look at setting up some automatic fire. Inside this function, we're going to call the line trace by channel function. We're going to get the one called line trace by channel. And we can hook it up to the execution pin, and we'll take a look at creating the start and end locations for the trace in a moment. We're not going to change the trace channel. Visibility is going to work fine for us. And we also don't need to worry about trace complex. Now we can provide actors that the trace can ignore, and usually we would want to ignore the actor that is calling the trace. So for example, the player wouldn't want to block the trace and cause damage to himself. But we can see that the function by default ignores self, so we also don't need to worry about setting up any actors to ignore. We can debug the trace so we can see it visually in the world. Let's turn this on. We're going to change the draw debug type to for duration. This will make the trace visually appear for a few seconds in the level. Okay, so let's figure out where we're going to start our line trace from. We want our line trace to spawn at the end of the weapon, at the same place where we spawn our muzzle flash particle. We can select our muzzle flash particle component in the components list, and we can see it's attached to a socket called muzzle flash, and this socket is a socket on the rifle weapon. We're going to get the rifle. We're going to drag out from the rifle and called get socket location, so we can get the location of a socket in the world. The socket is going to be the muzzle flash socket. That's all one word, and this is going to be our start location. So we're spawning our line trace from the same place that we spawn our muzzle flash on the weapon. We can select all of this, we can right click on it and collapse it down into a function called get weapon trace start location. And this can be a pure const function. And we can hit compile. Now we need to calculate the end location. To do this, we're going to create a new function called get weapon trace end location. And this is also going to be a pure const function. Now to calculate the end location of the trace, we're going to get the start location, and we're going to add this by a vector by dragging out the return value and putting in the plus symbol. Now what do we want to add this by? Well, we want to add it by the direction and the distance we want the weapon to fire in. So to get the direction, we can just call the get control rotation function. Then with the rotator that this returns, we can drag this out and we can find the forward facing direction by calling the get forward vector function. So this returns the direction that we want to fire the weapon in, and we can multiply this by a float to add the distance. And we can use this as the vector that we add to the trace start location. Instead of hard coding in the distance as a magic number, we're going to promote this to a variable called weapon range. So we can easily choose the range of the weapon. I'm going to hit compile and set the default value to something large like 5,000 units. Okay, now all we need to do is return this calculation as a value on our function. So we can add a return node, and then we can drag and drop this pin onto the return node. Okay, so this is actually our function complete now. We can hit compile and save, and we can come back to our weapon trace function, and we can now get our weapon trace end location and use it as the end location for our trace. So now let's come back to our level, and let's just drag in a cube into the level and scale it up a bit so we have something to shoot. And now when we play the game, you'll notice that when we fire the weapon, we are now performing our line trace, and we can see the debug preview. The trace fires in the direction that the player is facing in, and we can even see that it collides against the wall that we placed in the level. So our weapon trace is now working. But we want this trace to start causing damage to the aliens. But first, we need to make sure that the alien has health, and the health decreases when it takes damage. Pause here and create a health variable for your alien class, and remember to set the default value of the alien's health. Then implement the any damage event. Create a function that decreases the alien's health. Decrease the alien's health by the amount of damage being applied, and remember you should clamp the health after you decrease it. Then just for now, if the alien runs out of health, call destroy actor to remove the alien from the level, so it should be super obvious while we're testing if we've killed the alien. So pause here and set all of this up for your alien class, and remember we've covered all of this in the previous lesson, so if you get stuck, check out how we handle damage in the Marine blueprint. Okay, so inside my alien blueprint, I've created a new health variable for the alien. Whenever the alien receives damage, we decrease its health, and then if the health is equal to 0, we remove the alien from the level. Awesome, so hopefully you've implemented the health and damage system to your alien too. Now let's come back to our Marine blueprint so we can handle damaging actors when they are hit by the weapon trace. All the information about what the trace has hit is contained within this out hit pin. This is the hit result. We can drag this out and select break hit result to see all the details, and we can see that there's a lot of information here. Right now we only care about if the trace hit was successful, meaning if the trace hit anything in the world. And if it did hit something, we want to apply damage to the actor that was hit. So you'll notice on the line trace by channel function, we have this boolean return value. And on the hit result, we also have a boolean called blocking hit. These are actually both the same thing. They tell us if the trace hit anything in the world. So we can use a branch with either one of these, and we can hook up the execution pin. Then we can drag out from the pin that contains the actor that was hit by the trace, and we can type in apply damage. So if the trace hit anything, we can then apply damage to the hit actor. We can promote the base damage to a variable, and we can name this damage per shot. So we can now tune how much damage each weapon shot applies. We can hit compile and set the default value. I'm going to cause 25 damage per shot. Alright, so let's come back to our level. We can remove this cube, and we can drag in the alien so we can test shooting it. You'll notice if we hit play and start shooting towards the alien, our trace hits are just going straight past it and we aren't actually causing any damage. This is because of the default collision settings of Unreal's character class. By default, the character class ignores trace hits. So we're going to enter our alien blueprint, we're going to enter the viewport, and we need to remember that the alien doesn't have much height on it, so the player will most likely just shoot over the top of the mesh. But this is okay because our issue is not really going to be noticeable from a top-down perspective. The issue we have is that all the components in the character class are set up to ignore traces. We're going to make it so our trace collides with the collision capsule component. So we'll select the capsule, we'll scroll down on the details panel, and we're going to expand the collision preset. We can see that the pawn collision preset is set up to ignore the visibility trace channel. So to fix this, we're going to drop down the collision preset and we're going to select custom. And we're simply going to change the trace response for visibility from ignore to block. And now we can hit compile and save. We can come back to the level and hit play. We can shoot the alien, and now our traces are hitting and we're causing damage, and when the alien runs out of health, we destroy and remove it from the level. Alright, so in the next lesson, we're going to spice up the alien's death with a couple of effects, and we're also going to make it play its death animation. Hey, and welcome to this lesson where we're going to spice up the alien's death with sound effects and an animation. But before we get to this, we want to make sure that our weapon traces continuously execute while we are firing the weapon. So let's come to our Marine blueprint. And let's look at the logic where we fire our weapon. We're going to move our weapon trace function inside start firing weapon. We're going to put this on the end of the start firing weapon code. So we can drag out weapon trace and just call it on the end of this code. So when we start firing the weapon, we execute a single weapon trace, but we want to continuously execute the weapon trace function until we stop firing. To do this, we're going to set a timer. A timer is going to allow us to execute a function after a set amount of time. We're going to use a function in blueprints called setTimerByFunctionName. We have to provide the function name, the time it takes until the function executes, and with timers, we can choose if the timer loops. So this is going to be perfect for us to loop our weapon trace function while we're firing. Inside our start firing weapon function, after we call weapon trace, we're going to call set timer by function name. We're going to hook this up to the execution pin. We don't need to provide anything for the object pin. When we hover over this, it says it defaults to self. This means that it's going to look inside this blueprint with a function of the same name that we provide. The function name is going to be weapon trace. So we're going to set a timer on our weapon trace function. But the time is going to be our weapon fire rate. We can right click on this pin and promote it to a variable called weapon fire rate. I'm going to set my weapon fire rate to be 0.08 seconds, which should give us a nice automatic weapon feel. And we want to make sure that we loop our timer. So let's try this now. Let's come back to our level and let's hit play. And if we start firing once, you'll notice that the trace is continuously executing now. So we need to make it when we stop firing the weapon, we stop firing our trace. So back inside our Marine blueprint, we can come to the event graph and let's enter the stop firing weapon function. Before we check if the player is alive and we spawn our rifle and Q, we're just simply going to call the function named clear timer by function name. This function is going to allow us to remove our timer on our weapon trace function. So now let's try this again. Let's come back to the level and hit play. If we start firing, we're spawning weapon traces. When we stop firing, we are no longer executing our weapon traces. Awesome, so our weapon is acting like a fully automatic weapon now. So this is good. So our next step is to make our alien death more convincing. Head inside your alien AI blueprint and create a variable that stores if the alien is dead. Then create a new function called kill AI. Inside this function, set the alien as dead and call the function we created called deactivate AI movement. So when we call kill AI, we set them as dead and stop the AI's movement. Once you've done all this, call the kill AI function when the alien runs out of health. Okay, so inside your alien blueprint, you should now have a variable that we can use to store if the alien is dead. And you should have also created a new function called kill AI. And we call this after the AI runs out of health. We're going to kill the AI, then add a delay, and then destroy the actor. So once the AI is killed, we delay by, let's say, 3 seconds, and then we remove the AI from the level. Now inside the kill AI function, we set the alien as dead and we deactivate their ability to move. Now when the alien dies, we want to disable its collision so it's not going to block anything in the world. To do this, we can call the set actor enable collision function. We're going to hook this up with the execution flow and we're going to make sure that the checkbox is unchecked. So now when we kill the alien, we set it as dead and we disable its ability to move and we stop it from colliding with anything in the world. Now let's make it so the alien plays a death animation when we kill it. Let's come back to the content browser and to the characters folder and let's open up the animation blueprints for the alien. In the events graph, when the animation updates, we calculate the movement speed and we store it. Just next to where we do this, we are going to call the reference to the alien blueprint. We're going to get the dead variable from this, and we're going to store it as a variable inside the animation blueprint so we can actually call this inside our anim graph. Okay, so we're now storing if the alien is dead. So let's hit compile and let's switch over to the anim graph. We could add a death state to the state machine, but I'm going to show you one other way we could approach this. This way will also make sure that the attack montage can't be played on top of the death animation. We can grab our dead variable, let me just cancel this autosave, and we're going to move these nodes down here as well. We're going to drag out the dead variable and type in blend. We're going to get the node called blend poses by bool. This allows us to switch between different states or animations depending on the condition. So if the alien is not dead, we can allow our state machine and attack montage to play. We'll hook this up to the final result as well. But if the alien is dead, we can come to the asset browser, we can grab the death animation and we can play the death animation if the alien is dead. And we also want to make sure that we do not loop the death animation. So we're going to select it and we're going to uncheck loop animation on the details panel. Okay, so now the alien's animation blueprint is set up to play the death animation. You'll notice if we play the game now, when we kill the alien, it plays its death animation, and then after a few seconds it will disappear from the level. Awesome, so it's getting more convincing now. We can spice up the alien's death a bit by playing a sound effect when the alien dies. Inside the sounds folder, we have this Foley Flesh folder. We can come inside the mono folder, and there's some gruesome sounds that we can use for our alien's death here. And there's already an audio cue set up that we can use. We're going to use this Foley Flesh Gib cue. We just need to make sure that the mixer is connected to the final sound output. And we can play it just to preview it. And we can hear that this is going to sound pretty good for our alien death. Now we're going to spawn this as an anim notify when the death animation plays. Let's come back to the characters folder, inside the spider folder, inside the animations, and we're going to open up the death animation, whichever one the death one is. It's here. We can pause the animation, and at any point during this animation we can spawn this sound. We might as well just spawn it right near the beginning. So on the notifies bar, we can right click, we can come to add notify, and we can select play sound. We can select the play sound notify, and in the details panel on the top right we can assign a sound here. So the sound was Foley Flesh Gib. If we scroll down there should be a cue for it, and here it is. Okay, now if we play the animation, we can see it plays the sound with it. Awesome, so we can save the asset, we can close it, and let's try killing the alien now. Okay, awesome, so the alien's death is looking and sounding pretty convincing now. Remember, we have our kill counter on the player's HUD. This is bound to the variable called kills inside the Marine blueprint. Now I'm going to challenge you to set up some code to make the kills increase when the alien dies. Inside your Marine blueprint, create a new function called increase kills. Within this function, you simply want to increment the Marine's variable named kills. Then within your alien blueprint, call the Marine's increase kills function from within the alien's kill AI function. So whenever an alien gets killed, the kill counter will increase. And it's already bound on the player's HUD, so we should see this working immediately. So pause here to set up the kill counter. Okay, so I hope you had a go at setting this up. To do this, we're going to head inside the Marine blueprint. We're going to create a new function called increase kills. Within this function, we're going to get the variable that's named kills. We're going to drag this out, and we want to add 1 to this. So every time we call increase kills, we just increase the kills by 1. To do this, we can just put in the plus symbol, and we can call increment int. So this takes the kills and adds 1 to it and sets it for us, and we can hook this up to the execution pin. So that's our increase kills function complete. It's very simple. Now inside the alien blueprint, we want to call this whenever the alien dies. And at the moment, whenever the alien dies, we call the kill AI function. So within this function, we're going to right click and get the player character. And we can cast the player character to our Marine blueprint, which allows us to access the functions of the Marine with this reference pin here. We can drag this out and we can call increase kills. So now whenever an alien gets killed, we set it as dead, we deactivate its movement, disable its collision, and then increase the player's kills. Awesome, so let's hit compile and save, and let's come back to the level and let's try this out. So if we kill this alien now, we can see the kill counter is updating. We can actually select the aliens now, and we can hold down left alt and click and drag so we can spawn multiple aliens. And we can see that with each kill, the kill counter on the player's HUD is updating. Great, so this is feeling like it's really coming together, but there's a few loose ends that we need to tie up in our code before we go any further. With all of the code in the event graph for the alien blueprint, we're not checking if the alien is dead or alive. We only want to execute our code if the alien is alive. So I want you to pause here and create a function that returns if the alien is alive, just like we did with the Marine blueprint. Then only executes the AI movement code, the attack code, and the damage code in the event graph if the alien is alive. So pause here for this final challenge. Okay, so you should have a function that returns if the alien is alive, and this should be a pure const function. Inside the events graph for the alien blueprint, we should check if the alien is alive before we execute any of the code that makes the AI move towards the player. And we want to double check that when the AI succeeds or fails in moving towards the player, after we delay by 0.2 seconds, we want to make sure that we definitely do check again if the alien is alive. And when we damage the alien, we can also check if the alien is alive before we decrease its health and then go ahead and kill the AI if it has no health remaining. Then finally, we have the code that runs on the tick event. We have a condition that checks if the alien is within the attack range and if it's not already attacking. If this condition is met, then we can play the attack montage. But we want to expand this condition to take into the account if the alien is alive. We can add an additional pin on the AND node, then we can plug the isAlive function into the input. Now we can select all of these nodes and we can collapse these down into a function named canAttack. And this can be a pure const function. So that just makes that a bit neater there as well. Okay, so we now check if the alien is alive before we execute any of its core behavior. Now there's one more place we want to check if the alien is alive. It's inside the damage player function. I've already added the code here, but you want to check if the alien is alive before it goes ahead and damages the player. Okay, awesome. Now once you've done this, we can switch back over to the Marine blueprint. The Marine already has a function that returns if he's alive or not. We use this to disable the movement input and the weapon input if the player dies. But we can also use this when the Marine gets damaged, because there's no point executing any of the decrease health functions and killing the player functions if the Marine is already dead. All of these checks may seem unnecessary, but by adding them in, we're going to eliminate any bugs with the AI killing the player after the AI has been killed themselves. Now there's one more bug I've noticed that we can fix before we end this lesson. If you kill any aliens, you'll notice if you run around them, they will keep snapping towards the player as they are dying or as they lay dead. Luckily, this one's a really easy fix. Within the alien blueprint, when the alien runs out of health, we call the kill AI function. Inside this function, we call the deactivate AI movement. We deactivate its movement, but if it's still moving towards a target, it won't stop looking towards the location where it's moving. So to fix this, we're going to drag out from the character movement component, and we're going to call stop movement immediately before we deactivate its movement. So this will just fix that little issue we see now. You'll notice if you come back to the level and kill your aliens, they are no longer rotating around towards the player. Okay, so that wraps up this lesson. Our weapon now runs on a timer, we fixed some bugs, and the alien's death is a lot more convincing now. In the next lesson, we're going to start looking at how we can spawn the AI in waves. Hello and welcome to this lesson where we're going to take a look at spawning the aliens in waves. So we'll end up with this survival situation where the player has to survive as many waves as possible from the swarming aliens. Now, because we're going to be spawning the aliens in as waves, we don't want the aliens to exist in our level to begin with, so let's remove all the aliens that we've placed in our level. We can multi-select them in the world outliner and then we can hit the delete key. Okay, so first we have to figure out where we want the aliens to spawn during the wave. To do this, we're going to be placing down spawn points using Unreal's target point actor. Unreal's target point actor is a very simple actor. It's just an actor that we can move around in the level that has an icon assigned to it, and that's all it is. It doesn't have any other specific behavior at all. So this is going to be perfect for us to use as the spawn points for the alien. We want the aliens to swarm the player from all directions, so we're going to want to place spawn points outside and around the main play area of the level. So to find the target point actor, we can come to the mode panel and we can type and search for it. We can get the target point and we can click and drag it into the level. So right now I want you to pause here and place down target point actors in and around your level so we can use them as the spawn points for the aliens. And make sure that the spawn points are inside the navigation mesh in your level. If the alien spawns outside the nav mesh, it won't be able to move. So pause here to set up your spawn points and then we'll take a look at spawning the aliens in waves. Okay, so I've placed some target point actors around my level that I can use as spawn points for the aliens, and I've also made sure that the target points are within the nav mesh. Remember, you can press P to toggle the visibility of the nav mesh. And just to let you know, you can also change how large the icon is for a target point by adjusting the editor billboard scale in the details panel when you have a target point selected. Okay, so for each wave, we want there to be a limit to how many aliens spawn, and then as we complete each wave, we want more and more aliens to spawn. But where are we going to start coding all this wave spawning logic? Well, we're going to code it inside our Mars Marine game mode. So let's open this up. When you open it up, you might see a window like this, but we want to open the full blueprint editor for this. Our first objective is to have a variable that contains what the current wave is, and we're also going to display this on the player's HUD. So let's create a new variable, and let's call this current wave, and let's make sure that this variable is of type integer. And we can hit compile. We're also going to create a new function called setupNewWave, and inside this function, we're going to get the current wave, and we're going to increase the value of the wave by 1. So we're going to just drag it out and put in the plus symbol, and we're just going to increment it. We're going to be adding more code to this, but for now, we're going to come back to the event graph, and we're going to say on begin play, when the game starts, we're going to delay by, let's say, 2 seconds, just a short little time here, and then we're going to set up a new wave. And this is just going to increase the current wave. So it's not doing much right now, but we're going to come back to our level. We're going to come to the UI folder in the content browser and then open up the player HUD. Now we're going to add in a new text block, so we can come to the palette and drag out a new text block. We're going to place this on the top center of the player's HUD. So let's set the anchor point to the top. Let's just drag out the text here a bit, and let's customize what the text is going to say. It's going to say something like wave 7, if we were on wave 7. We're going to set up a binding for this in a second, but let's just set up the text. We want to change the text justification, so it's always in the center, and we kind of just want to line it up with the center of the anchor point. And we can also change the font color here. I'm just going to change it to a nice bright blue. Okay. Now let's set up a new binding for this. We're going to create a new binding. We're going to change the function name to update current wave. Now to update the current wave, we are going to right click and call the function named getGameMode. So we can get the game mode, but first we have to cast it to our Mars Marine game mode so we can gain access to its variables and functions. And with the reference pin on the cast, we can drag this out and we can get the current wave. Now we don't want to plug this straight into the text right now. We're going to drag out from the text and we're going to convert the text to a string, which allows us to append the string. So we can create a string that says wave, and we can add a space here and then plug the value of the current wave into the second input. And we can hook up the cast to the return node. Okay, so we get the current wave from our Mars Marine game mode, and we set up some text which displays it. And it's already bound to our text block on the UI here. So we can come back to the level, and we should see now when we hit play, we can see it displays the wave, and after 2 seconds, the wave increases. Now we're going to make it so as soon as the wave increases, we start spawning the aliens and they start running towards the player. But there's something we need to understand first about spawning AI. When we manually place character blueprints into the level and start the game, if the character is not already possessed by a player, an AI controller will automatically spawn and possess the character. But if we spawn a character blueprint at runtime, an AI controller does not spawn and possess the character automatically. So this is going to be an issue when we spawn our aliens because by default they won't have an AI controller. So to fix this, I want you to pause here and open up your AI blueprint and try find the setting in the class defaults that you can change that adjusts the behavior of possessing AI. Okay, so I hope you found it. If you come inside your alien blueprint, when you have the class default selected, you can see there is a auto possess AI setting. By default, it's set to placed in world. we can simply drop this down and change it to placed in world or spawned. This means when we spawn this AI character now, a controller will automatically spawn and possess it. Okay, so let's compile and save this blueprint and close it to come back to our game mode. We're going to create a new function called spawn alien. Inside this function, we want to spawn an alien randomly at one of the target points we placed in our level. So we're going to create another new function, and we're going to call this getRandomSpawnPoint. Inside this function, we're going to call the getAllActorsOfClass function. We are going to want to get all the target point actors, and this returns an array of all the target point actors that exist in our level. We can drag out from the array pin, and we can use an array function called get. This allows us to provide an index to get an element of the array of target points. Now we want to get a random element, so we're going to drag out from the index. We're going to type in random integer, and we're going to get the random integer in range function. We want the range to go between 0 and the last index in the array. We can drag out from the array, and we can call the last index array function. We're going to use the last index as the maximum range input. So this will now get a random target point that exists in our level, and we want to return the result here. So we're going to add a return node. We're going to drag and drop the pin onto the return node, and we can just call the output pin spawn point. And let's make sure that we hook up all the execution pins in here. Okay, so this is this function complete. We can hit compile, and we can come back to our spawn alien function. Inside this function, we can call the getRandomSpawnPoint function. So when we spawn an alien, we get a random spawn point. We can check if the spawn point is valid. We always want to make sure that the spawn point is valid before we use it. And if it is valid, we can then call the spawn actor from class node. We can spawn our alien class, so we're going to search for the BP alien. And we have to provide the spawn transform. We're going to provide the transform of our random spawn point. So dragging out from the spawn point, we can call the getActorTransform function. Okay, so this spawn alien function is now going to spawn an alien at a random target point in our level, and the alien should start running towards the player and attacking them straight away. But we're not yet calling this function in our code anywhere yet. Let's hit compile and save, and let's come back to the event graph. We're going to create a new custom event. We're going to right click and come to add event, and we can select add custom event. We're going to name this spawn wave. When we spawn a wave, we're going to call spawn alien. Okay, it looks very simple, but we're going to call the spawn wave custom event on a timer. Let's head inside the setup new wave function. Inside this function, we are going to call the set timer by function name. The function name is going to be the name of our custom event, which was spawn wave, and we're going to loop it and call spawn wave every second. Okay, so this means that when we set up a new wave, we increase the current wave number, which will increase the value on the player's HUD, and then every second we're going to start spawning aliens to run towards the player. So let's save all, let's hit Control, Shift and S, and let's come back to our level to test this out. When we play the game now, and when a new wave starts, the aliens are going to endlessly spawn every second and come and attack the player. So we're almost there, and in the next lesson, we're going to limit how many aliens are in each wave. And we're also going to make it more difficult for each wave. We're going to increase how many aliens spawn in each wave. So that wraps up this lesson. I'll see you in the next one. Okay, so we're going to be wrapping up spawning the aliens in waves in this lesson. We've got a few objectives. We want to keep track of how many aliens are currently alive during a wave. And we also want to limit how many aliens can spawn during a wave, and with both of these, we're going to be able to tell when there's no aliens remaining during a wave. So to end a wave, we want to make sure that no aliens are alive and that the aliens have no spawns remaining. To wrap up our wave spawning, we want to add a difficulty feature. The game should start easy with less aliens, and then with each wave, more and more aliens should spawn, making it harder for the player to survive. So let's start with our first objective of keeping track of how many aliens are alive. To do this, we're going to add each alien to an array when they are spawned. The length of the array will be able to tell us how many aliens are currently alive in the level. But we need to make sure that we remove the aliens from the array when they are killed. So your first challenge right now is to head inside your Mars Marine game mode and create a new variable called aliens. Make it a BP alien object reference and make sure it's an array. We will use this array to store the aliens that are currently alive. To do this, whenever you spawn an alien, add the alien that gets spawned to the array. Okay, so pause here to set up the code to add your aliens to an array when they spawn. Okay, so I've created a new BP alien array just named aliens inside my game mode. Whenever we spawn an alien, we want to add them to this array. So let's enter the spawn alien function inside our game mode. We spawn the alien, we can check if it's valid first, so we can call the isValid macro. So if it is valid, we can then get our aliens array, and we can add the alien that gets spawned to the array. To do this, we can drag out from the array and call the add function, and we can provide the spawned alien as the element we want to add to the array. Okay, but we want to make sure that when we kill an alien, we remove it from this aliens array. So we're going to create a new function, and we're going to name it something like register alien death. We want to call this function when an alien dies. When they die, we will get our alien array, and then we're going to remove the alien that died. We're going to call the remove item function on the array. We're going to drag the input pin for the item onto the function entry node. So this creates a new input parameter. Let's make sure the execution pin is hooked up. We're going to rename the input parameter to alien. So this will add an input pin when the function is called, so we can provide the alien that we want to remove from the array. And this is all we're going to do in the function for now. We can hit compile and save, and we can head over to the alien blueprint. We call kill AI when the alien dies. Now we can come inside this function, and we can make it so whenever we kill the alien, we register the alien's death. To do this, we are going to get the game mode. We're going to cast it to the Mars Marine game mode. We're going to hook up the execution pin, and because we cast it to the Mars Marine game mode, we can use the reference pin to gain access to its functions. We're going to call our register alien death function, and we can see here we can provide an alien. We're going to use self as this input. So this means that whenever this alien blueprint is killed, we register its death in the game mode. So with all the code that we've just set up, it now allows us to keep track of how many aliens are alive by adding them and removing them to the array in the game mode. Our next step now is to limit how many aliens can spawn in a wave. And I want you to get us started with this one too. Inside your Mars Marine game mode, create a new variable of type integer and set a default value for it. This will be the limit on how many spawns the aliens have. And then whenever you spawn an alien, decrease the amount of spawns the aliens have. So pause here to do this, because once we have this set up, we can move on to ending and completing waves. Okay, so I hope you had a go at this. You should now have a new variable inside your Mars Marine game mode that we can use to store how many spawns the aliens have in a wave. Now I've set a default value of 10 for this. And we want to decrease this value whenever we spawn an alien. So inside the spawn alien function in the game mode, after we spawn an alien, we check to see if it's valid, and then we add them to the array. But after this, we're going to get how many spawns they have remaining, and we're going to decrease it by 1. We're going to call the decrement int function. So we decrease how many spawns they have, then we're going to check to see if their spawns are equal to 0. Okay, so we now spawn an alien, we add them to the array to say that they are alive, but if they have no spawns remaining, we're going to want to stop them from spawning. Remember, in the event graph, we have our spawn wave custom event, which executes our spawn alien function. This event is called on a timer. So to stop them from spawning, we're going to clear the timer. we're going to drag out from the true output of the branch and call clear timer by function name. The function name is the name of the event which is spawn wave. Okay, so now whenever we spawn an alien, we decrease the amount of spawns they have, and then we stop the timer from executing if they have no spawns remaining. Awesome, so let's compile and save our work, and let's come back to the level to try this out. So we have to wait a few seconds for the wave to start, then the aliens are going to spawn and start chasing the player. Now if they seem like they're taking a while to get to you, you can always move the spawn points closer. So we should start killing the aliens, and once we kill them all we should only have 10 kills. And for me, once we reach 10 kills, the aliens should stop spawning. And I'm at 10 kills now, and the aliens no longer spawn because we limit how many spawns they have in the wave. Now the next step is to end the wave if the aliens have no spawns remaining and if we've killed every alien in the level. Then we can wait a few seconds before starting a new wave. So we're going to start this by creating a new custom event inside the event graph of our game mode. This event is going to be called end wave. Whenever end wave is executed, we are going to delay by, let's say, 2 seconds for now. Then we are simply going to start a new wave by calling setup new wave. Now we want to make it so when we kill every alien in the level and when the aliens have no spawns remaining, we're going to execute end wave and then delay by 2 seconds and then start a new wave. To call end wave when this happens, we're going to enter the register alien death function. Once an alien dies, we remove them from the aliens array. We're going to check if the array is empty once we do this. So let's get the array. We're going to drag it out and call the array length function. And we can check to see if it's equal to 0. But we're going to drag out the Boolean result of this and type in AND. We're going to get the AND Boolean function. We only want to end the wave if there's no aliens remaining in a level and if the alien spawns remaining is equal to 0. Now we can use a branch with this, and this can be our condition. We're going to collapse all of this down into a function, and we're going to name this isWaveComplete. This is going to be a pure const function. So now whenever any alien dies and we register their death, we check to see if the wave is complete. If it is complete, we're going to call our end wave custom event. So once an alien is killed, we register their death by removing them from the array of aliens that exist in the level. Then we check to see if every alien in the level is dead and if there's no more aliens in this wave. If this is true, we then end the wave. Okay, so let's try this out. Let's hit compile and save. Let's come back to our level and hit play. So once a wave starts, aliens will start spawning in and then running towards the player. Once we kill all of the aliens in a wave and they run out of spawns, the wave will end, and then after a short delay, a new wave will start. Then the same thing happens again, so we have a loop now that aliens will keep coming until we wipe out the wave, and then the next wave will start. Awesome, so we're really close to having our AI wave spawning complete. Our next step is to add a difficulty feature. We want to make it so each wave spawns more and more aliens, making it harder for the player to survive as each wave goes on. To do this, we're going to create a new function in our game mode, and we're going to call this increase wave difficulty. We're going to start with a difficulty value. When we execute increase wave difficulty, we're going to take the difficulty and multiply it by another value we will call difficulty multiplier. So as an example, if we had 5 aliens, then we multiplied them by 1.5, we would end up with 7.5 aliens. Now of course we can't spawn 7.5 aliens, so we're going to round the result. So basically, we're going to take the difficulty value every wave and multiply it by the difficulty multiplier. Then we're going to use the result as the amount of spawns the aliens will have in the wave. This means that the waves are going to become more and more increasingly difficult. Let's create a new variable and let's call this wave difficulty. This is going to be an integer. We can compile and set a default value. I recommend using 5 to begin with. Then let's add another new variable called difficulty multiplier. This is going to be a float. We're going to compile and assign a default value to this. I'm going to use 1.5. I'd recommend using 1.5 as well to begin with. The difficulty multiplier is really going to affect how hard your game is. The higher this difficulty multiplier, the harder the game is going to be. Inside the increase wave difficulty function, we're going to get the wave difficulty. We're going to multiply it by a float. We're going to multiply it by our difficulty multiplier. Then we're going to round it. Once we've rounded this value, we can set the wave difficulty. So this means that every time this function executes, we're going to take the wave difficulty and multiply it to make it a larger value. But we're going to take the wave difficulty and use it as the amount of spawns the aliens will have. So let's grab our alien spawns remaining. Let's drag it out onto the graph and let's use a set. We're going to use the wave difficulty as the amount of spawns that the aliens are going to have in the wave. Okay, and that's our function complete. We can hit compile and we can decide where we're going to place this function. We're going to execute it inside the setup new wave function when we start a new wave. We can actually rename this function just to be consistent. This is going to be start new wave. So inside this function, when we start a new wave, before we start spawning the wave, we are going to increase the wave difficulty. Okay, so we can hit compile, we can hit save, we can come back to our level and play the game. Okay, so you'll notice now that as you complete waves, you're going to have to keep killing more and more aliens. Now, if you wanted to make the base game difficulty even harder, there's one final thing we can do. We can promote the time on our spawn wave timer to a variable named spawn frequency. Instead of being 1 second, we can lower the time it takes between each alien spawning. You'll notice that it makes more aliens appear at once and making the game even harder. So it's up to you to tweak and tune the difficulty parameters of your game. Have fun and take some time to tune your game before moving on to the next lesson. Hey, and welcome to this lesson where we're going to wrap up development for our Mars Marine game. We're going to start this lesson by removing the debug lines from our line trace. Then we're going to spawn some impact particle effects wherever our line traces collide. So let's get started by heading inside our marine blueprint. Whenever we start firing our weapon trace function executes. So inside this function, we have this line trace by channel function. We have the draw debug type set to for duration. We're going to change this to none to remove the debug lines. Now to spawn some impact hit effects, we're going to want to spawn a particle whenever we know that the trace has hit something. And we can tell if the line trace has hit anything by making use of the blocking hit from the hit result with a branch. And we're already doing this here. So we're going to want to insert a function around here. We're going to create a function for spawning the impact hit at a particular location in the world. And you'll notice on the hit result we have a world location. So we're going to make use of this too inside our function. But I want you to create the function. Create a new function named spawn impact hit. This function is going to need a vector input parameter. This will be used for providing the trace hit location. And inside this function, we want to spawn a particle at a location. So call the spawn emitter at location function. The emitter we want to spawn is the assault rifle impact hit from the effects folder that's provided with the content in our project. For the spawn location, make use of the hit location input parameter. Then once you've created this function, call it whenever the weapon line trace hits anything, and make sure to provide the hit location from the trace hit result for the input on your function. Okay, so this is your first challenge for this lesson. Pause here to create a function for spawning the impact hit. Okay, so I hope you had a go at this. You should now have a function named spawn impact hit inside your marine blueprint class. This function should have a vector input. I've named it hit location. It could be hit location or spawn location, but we use this vector input parameter as the location where we spawn our emitter. And the emitter is the assault rifle impact hit. We can see when we drop this down, it's just around the fourth one down here. Okay, so inside our weapon trace function, we're going to call this spawn impact hit. We want to call it after we have a blocking hit on the trace. So it's going to be after the true output of the branch here. So we can call it before or after the apply damage function. I'm going to put it on the end of this code here. And the hit location is going to be the location from our hit result from the line trace. And we can just neaten this up a bit by double clicking on these wires. Okay, so now anytime we do a line trace, if it hits anything in the world, we spawn our impact hit in the world as well. So let's hit compile and save, and let's come back to the level to try this. So if I shoot at these rocks, we can see the impact hit, and once the aliens come, the impact hit should spawn on the aliens as well, which should be any second. There we go. Okay, cool. So for the second half of this lesson, we're going to spend some time setting up a health pickup, because the player should be able to replenish their health. Now, in order for this to work, the Marine Blueprint class is going to need a function to add health. Once we have this, we can start setting up a health pickup blueprint class. When the player overlaps the health pickup, it should call the add health function, and then it will destroy the actor and remove itself from the level to represent the player collecting the pickup. But we want to make sure to only allow the player to collect the health pickup if the player's health is not already full. So let's take a look at doing this. Inside our Marine Blueprint, let's create a new function named add health. To add health to the Marine, we're going to come to the player properties category under the variables, and we're going to get the player's health. We're going to drag out the health and put in the plus symbol to get the float plus float. So we're going to get the health, and we're going to add it by a value, and we're going to drag out the second pin here and drop it onto the input entry function node here to create a new input parameter. We're going to name this health to add. So whenever this is executed, we get the health and then we add to it. We need to clamp the health. We can clamp it between 0 and the maximum health, which is going to be 100. And then we can grab our health variable again and just set it. And we can use the return value from the clamp. And let's just make sure we hook up our execution pin. And this is our add health function complete. We can hit compile and save. Now there's one more function we need to create. Let's create a new function again, and let's name this one is health full. This function is going to be a pure const function. We're simply going to get the health and see if it's equal to 100. And then we're going to add our return node, and we can drag and drop the result onto the return node here. So this function returns if our health is full or not. Now we're ready to set up our health pickup class. Let's hit compile and save in the Marine Blueprint, and let's come back to the content browser. Let's come to the Blueprints folder, and let's create a new folder called Pickups. Inside this folder, we're going to create a new blueprint class, which is going to be an actor, and this is going to be named BP_health pickup. Now let's double click on our health pickup to open it. Inside our project, we have a health mesh asset that's set up as a particle. It automatically spins and it has a color applied to it. Now we're going to use this particle for our health pickup. So we're going to add a new particle system component, and this is going to be named health particle. And it's also going to be the root component, so we can click and drag and drop it on the default scene root to remove the default scene root and make the health particle the root component. Now we can drop down the particle template, which is the particle asset we want to assign to this, and we can just type and search for health, and we can get the P_health particle system. So here we have a spinning health mesh asset. Now we're going to add a sphere collider around the mesh. So let's add a new sphere collision component, and this is going to be called collision component. And we can just move it up so it surrounds the health particle. Okay, great. So these are all the components we need for our health pickup. Now I want you to set up the code for this class. Whenever any actor overlaps the health pickup, cast to see if the actor is the Marine Blueprint. If it is the Marine, find out if the Marine's health is full. If the Marine's health is not full, add health to the Marine and then destroy the health pickup. So pause here and have a go at coding the health pickup class. Okay, so I hope you had a go at setting up your health pickup. We have the event actor begin overlap. So whenever any actor overlaps the health pickup, we check to see if it's the Marine by casting to the Marine blueprint. Then we check to see if the Marine's health is not full. So we get the is health function and use the not boolean with this, and then we use the branch. So if the health is not full, we will execute the true output, and then we can add health to the Marine. Once health is added, we then destroy the health pickup. So it's pretty simple. Okay, so this is our health pickup complete. We can close this, we can close the Marine blueprint, and we can drag some health pickups into our level. So let's just add a handful, and let's hit play, and let's test this out. So I'm going to wait till some aliens come up and attack me and decrease my health a bit, and then I will pick up my health. So our health is decreased. Now if I go pick up some health over here, we can see that it restores the health. So you'll notice that my health pickup actually has a health variable here that I set up. So this is just so I don't have to hard code in any value into this function. We just have a health pickup amount for our pickup class. Awesome, so this is our health pickup complete, and we also spawn some impact hits whenever our trace hits anything. Now in the next lesson, we're going to take a look at setting up the boundary that a player can't escape from. So once you're ready, I'll see you in the next lesson. Hey, and welcome to this final lesson for the Mars Marine section. Now in this lesson, we're going to cover creating a system that restricts the player to a particular play area. If the player leaves the mission area, a warning will be displayed, and if the player doesn't return to the mission area, the player will be killed. So where do we get started with this? Well, first we're going to set up the warning text that we're going to display if the player leaves the mission area. Let's come to the UI folder in the content browser, and let's open up the player HUD. Now let's come to the palette, and let's drag in a text block onto the canvas. We're going to place this just above the center of the canvas. Let's set the anchor point to the center of the canvas, and let's just scale the text block up a bit so we can see the center of these two circles kind of line up with the anchor point. And let's change the appearance of the text block. Inside the appearance category on the details panel, we can change the justification so the text is centered. Now we want the text to look like a warning, so let's change the text color to red. We can just bring down the green and the blue values here to make it fully red. Okay, now let's change the text that's displayed. Let's write a message all in capitals, something like warning, imminent death, and we can press shift and enter to start a new line, and we can enter something like return to the mission area. Now when we hit enter, we can see our text displayed here. So this looks okay, but at the moment when we play the game, this is going to be visible. With the text selected, on the details panel, we can scroll all the way down and we can change the text visibility. Let's change it to hidden for now. We'll come back to this shortly. We can hit compile and save, and we can come back to our level. Our next step is to set up a variable inside the Marine blueprint that stores if the player is inside the mission area. Let's come to our Marine blueprint, and let's create a new variable, and we can just name this outside mission area. And we want to make sure that it's a boolean, and we want to make sure that if we compile, the default value is set to false. Okay, that's all we need to do in our Marine blueprint. We can save it and we can close it. And where we set the visibility inside our player HUD, we can create a new binding. Let's change the name of the function that gets created for the binding to something like set mission area warning visibility. We're going to change the mission area warning visibility depending on if the player is in the mission area. To do this, we are going to get our Marine blueprint. So we have the reference for the Marine here. We can get the outside mission area variable we just created. Now, how do we change the visibility drop down here? We can see there's lots of different selections. How do we change this depending on the result of this boolean? Well, we can drag out the input pin here and we can type in select, and we can use the select node. We can see we have two options here, and we have this thing named index. Let's plug our outside mission area boolean into the index. The select node simply allows us to change the selection depending on the variable. So if the outside mission area is true, the mission area warning will be visible, but if it's false, we can set it to hidden. Okay, and that's our binding set up. It's going to toggle the visibility of our mission area warning depending on if the player is inside the mission area. So we can hit compile and save, and we can close this widget. Okay, so we now have a variable that stores if the player is outside the mission area, and the HUD is going to reflect this. Now I want you to create a custom volume that we can use for our mission area. Pause here and create a new blueprint actor. Name it BP Mission Area Volume. Add a box collision component to the volume, then set up the event graph for this actor. Whenever the player overlaps the actor, set the outside mission area variable within the Marine blueprint to false. This would mean that whenever the player enters this volume, they are within the mission area. Then once the player ends an overlap with this actor, set the outside mission area to true. This would represent the player leaving the mission area. So pause here to create your mission area volume, and then we'll take a look at triggering the player's death if the player stays outside the mission area for too long. Okay, so I hope you had a go at this. I now have a new blueprint actor named BP Mission Area Volume. Inside this actor, I've just added a box collision component to use as the trigger for the volume. Inside the event graph, when anything leaves or enters the volume, we check to see if it's the Marine. If the Marine enters the mission area, we set the outside mission area variable within the Marine blueprint to false. And if the Marine leaves the mission area, we set it to true. Now let's test this out. We can come back to our level, we can drag out our volume, and we can scale it up so it covers the level. We probably want to make sure that the alien spawn points are outside of it, and we want to make sure that the player start is within this volume. Now once we've scaled up the volume, we can hit play, and if we try leaving the mission area now, a warning should get displayed telling us to return to the mission area, which it does. When we return to the mission area, the warning goes away. But of course, if we leave the mission area and stay out of the mission area for too long, the player doesn't actually die yet. So let's fix this. Let's come back to our mission area volume blueprint, and let's create a new function called kill player. When this function is called, we're simply going to get the player character, and we are going to apply damage to the player. We're going to apply 100 damage to the player to kill them. Okay, now how do we call this function? Well, we're going to call it on a timer. Whenever the player leaves the mission area, we can set a timer by function name. The function name is going to be kill player. And how long do we want to wait until the player dies when they're outside the mission area? We can promote the time to a variable, and we can call this seconds before player death. This can be compiled, so we can set the default value. I'm going to choose 5 seconds for this. So whenever the player leaves the mission area and they're outside it for 5 seconds, the kill player function will execute. But if the player returns into the mission area, we want to clear the timer. So let's make sure that we call the clear timer by function name, and the function name is going to be kill player. So whenever the player returns to the mission area, we clear the timer. Okay, that's all we need to do in our volume. We can hit compile and save, and we can come back to our level and hit play. So if we leave the mission area now and stay outside of it for too long, the player should now die. Okay, so that brings us to the end of Mars Marine. You've now completed this section, but there's still a lot more that you could add to this. There's so many more things that could be added to this game to flesh it out more. You could fade the camera out when the player dies, and then restart the level or open a different level. You could create your own unique pickups for the player, different types of levels and aliens, different weapons, power-ups, abilities, game modes, the list goes on. But why not head over to the Game Dev TV community forum and team up with a few fellow students to keep developing your game? If there's one thing I want you to take away from this section, it's the use of pure const and impure functions. By writing good readable code that's collapsed down into these functions, you can hide all the messy details and easily understand your code from the top level. We've created a few variables and functions across our classes. Just make sure that these have good names that describe them and take some time to organize them into categories. So that's the end of this section. I hope you've had fun with it and that you feel like you have a game that you can continue developing. When you're happy with your game, remember, you can always package it to share with your friends.